great pleasure to welcome all participants attending in person and online to the International Symposium on Trust Measurements of a Sustainable Energy Future, jointly organized by the National Institutes of Metrology Thailand, the Asia Pacific Metrology Program, Energy Efficiency Focus Group, endorsed by Ministry of Energy Thailand, officially supported by Ministry of Higher Education, Science, Research and Innovation Thailand, and informal markets. We are now honored to have you join us for these important gatherings of experts, researchers, and stakeholders committed to advancing measurement science in support of sustainable energy future. I am Rakhanawan Mongpathiadesai from National Institutes of Metrology Thailand, and I will be serving as a Master of Ceremonies for today's event. The symposiums feature 2 sessions of talks and 2 panel discussions, bringing together distinguished experts to share their knowledge and insight. The symposium aims to establish and harmonize international metrology and measurement standards that drive the global transition to clean energy by ensuring accuracy, testabilities, and reliabilities. These standards will support innovation, enhance investment confidence, and foster inclusive participation in sustainable energy systems worldwide. Ladies and gentlemen, before we commence the symposium, I would like to briefly outline the program for today's event. We will hear a series of technical presentations from our distinguished speakers on the following topics: policy frameworks for emerging renewable energy technology, from clean energy to trust claim, maximizing business value in the net zero era, measurement for emerging energy system, EU experience in hydrogen energies and CCUS, China implementations of energy measurements for efficiencies and carbon reduction, trust measurements and bankability, perspective on green energy financing. The last one, why technical measurement excellence is the key to PV and green energy projects. Following the presentation, we will gather for group photo sessions. After that, we will have a lunch break and then continue with 2 panel discussions: trust measurements for hydrogen and emerging energy, and trust measurements for sustainable solar energy. Finally, the symposium will be wrapped up with a summary of the key highlights. For more information, please refer to the symposium program schedule. For our opening remarks, may I invite Dr. Charanya Phả, Assistant Director of National Institutes of Metrology Thailand, to take the stage and deliver an opening address. Ladies and gentlemen, please welcome him warmly.
Professor Ravi Fernandes, distinguished guests, esteemed colleagues, and valued partners. Good morning, everyone, both in this room and online. It is my great honor to welcome you to the International Symposium, Trust Measurement for a Sustainable Energy Future. Today, we gather not only to advance renewable energy and measurement science, but to strengthen collaboration across nations, institutes, and disciplines. This symposium represents a unique opportunity to share expertise, foster innovation, and build trust framework that support our collective journey toward a sustainable and finally net zero future. So on behalf of NIMT, I extend my deepest appreciation to all speakers and participants, and also the funding to the APMP as well, and everyone who contribute to this dialogue. May our discussion today inspire our new partnerships, practical solutions, and last for a collaboration. We work together. I sincerely wish this symposium great success, and that together we achieve outcomes that benefit both Thailand and the global community. I declare the symposium opening. Thank you very much.
Thank you very much, Dr. Jaran, for your warm welcomes. Next, we are pleased to hear a welcome message from Dr. Oijai Ongrai, Chair of Asia Pacific Metrology Program, Energy Efficiency Focus Group. Dr. Ongrai, the floor is yours now.
Distinguished colleagues, ladies and gentlemen, it is my privilege to stand here at the International Symposium Trust Measurement for Sustainable Energy Future. Today, we are not only exchanging the knowledge, but weaving together a fabric of collaboration that stretches across the continent and discrete line. Trust measurement is the invisible backbone of every renewable energy project, from solar to hydrogen, ensuring confidence, safety, and bankability. As a chair of Asia Pacific Metrology Program, Energy Efficiency Focus Group, I am proud that Thailand, through NIMT, can host this dialogue and connect our expertise with global partners and at the great event ASEW 2026. May our discussion today spark innovation, strengthening collaboration, and lead to the practical solution that bring us closer to a sustainable net zero future. With that spirit of collaboration, I now would like to come to our Master of Ceremony, Fa Rakanawan, to guide us through this exciting program. Sora, back to you. Thank you.
Thank you very much, Dr. Ongrai. We will now begin the first technical presentation sessions. Our first speaker is Mrs. Munlika Sompranon, Director of Division of Solar Energy Development at the Department of Alternative Energy Development and Efficiency, Ministry of Energy, Thailand. She has extensive experience in renewable energy policy and solar energy development, leading national initiative and promoting regional collaboration to support Thailand's clean energy transition. She will deliver a presentation entitled Policy Framework for Emerging Renewable Energy Technology. Please join us in welcoming Mrs. Sompranon.
So, good morning, everyone. My name is Munlika Sompranon. As she has already mentioned, I come from Department of Alternative Energy Development and Efficiency, Ministry of Energy. So, so thank all of you that to join us today. So my presentation, the topic of my presentation today is Thailand solar energy. So this one is, I think, is the crucial issue that's for normal that we have heard from the media every day that we would like to promote the solar, even is for the focusing for the household right now. So let me start with the outline of my presentation. The outline of my presentation is first about the Thailand greenhouse gas emissions. So I will give you the big picture of the national climate commitment and the strategy for reducing emission. Next, about the Thailand energy policy. I will look at the macro policy framework and master plan integrating solar power into our energy mix, and then the installations. So about the solar, the Thailand current solar capacity and ongoing project. And the last one is supporting policy is we will cover on the intensive regulations and financing mechanism to driving this growth. So next slide, please. The Thailand greenhouse gas emission strategy. So Thailand has established a clear long-term roadmap to tackle greenhouse gas emission across 5 key sectors: land use, agricultural, and waste, energy, and industrial processes and products used, or in short, it's called IPPU. So our strategic timeline focuses on 4 major milestones. By the year 2030, it will reduce overall greenhouse gas emission by 40%, and by the 2035, to achieve at 69% of EV share of on new vehicle, and by the 2050, we have to reach full carbon neutrality, and also I think should be updated to. Not we have also achieved the fully the net zero greenhouse gas emission by the year 2050, not 65. Next slide, please. Now I come to the National Energy Plan. In short, we call NEP. In this plan, they have the 4 major policy pillars driving Thailand transition toward clean energy and carbon neutrality. So the first is an ambitious target ensuring the more than half of all newly built new power plant will utilize renewable energy sources such as solar, wind, and floating solar. Not only this one, also they have the biomass integrated with the energy storage system to guarantee grid stability. Next is about we have a pledge to increase national energy efficiency by more than 30%. And 30%, this we will accomplished by the implementing modern energy management system and high efficiency technology across the industry, transportation, agriculture, household, and also the building sector. 30 at 30 EV promotion, the national electric vehicle blueprints. The goal is to have battery electric vehicle account for 30% of total automotive production by 2030. So, and the last one is about 4D1E strategy for energy transition. The core is this one is stand for decarbonization, shipping toward low carbon and clean energy, digitalization, applying smart grid and AI to manage the power networks, decentralization, speeding energy productions via distributed sources like community power system and rooftop solar, deregulation, reforming regulation to facilitate the energy innovation, sandbox, and also peer-to-peer energy trading. And the last one is the electrification to speed up the use of electricity to in other sector, particularly in transportation sector via through EV. So that the next slide is about the evolution of renewable energy plans. The development of our renewable energy and alternative energy development plan over the last 2 decades, you can see that the massive paradigm shift will start under the REDP. REDP stands for Renewable Energy Development Plan, with an overall renewable energy target of 20% and a small solar goal of 500 megawatts. If we look at to the futures, that the new draft AEDP stands for Alternative Energy Development Plans 2024. Our overall renewable energy share target has risen to 37%, a relative increase of 85% in the total renewable energy ambitious. So more importantly, our solar energy target has a scale to 41, is more than 41,000 megawatts. So this is increase around like 8,255% increase for our value from our first solar target. So this is as you look at the growth of the solar energy in Thailand is very significantly. So move to the in detail. So in detail, as you look at the for the solar in the primary driver of Thailand future energy mix, total solar power target is set at the an ambitious. As I told you before about it, 41.7 thousand megawatt. So combining about the like 38.9 megawatt of land and rooftop solar with the 2.8 of megawatt of the floating solar. So in the future, we expect that energy, renewable energy and import of to command at 61% share of Thailand total power generations. So this one, the next slide is about that. So next slide, please. So next slide is back into the 2012. We start with the total capacity of just 437 megawatt peak. By 2024, that the number jumped to 6,000.8 megawatt peak. So this is an enormous scope of 1.4% in just 12 years. Why most of the growth historically come from the large-scale project with the government contract shown in dark screen. I want to focus on the raised orange bar starting in 2029. This is our on-grid with our PPA sector, which is mostly private sector rooftop built for self-consumption. So in just 5 years, this rooftop sector alone shows up from 475 megawatt peak to 2,934 megawatt peak. So this is too much to jump up. It's around like 517%. So the supporting measure, I think all of you that know about feed-in tariff, and before this we use the adder. Adder is implemented in the the adder era is between the year 2007 up to 2010. So we this one is we with the paid at a high bonus on top of standard of the standard electricity rate up to 8 baht per unit guarantee for 10 years. And then we switch to the FIT between the year of 2014 up to 2015. This one is we targeted 100 megawatt each for residential and smaller commercial rooftop, and 800 megawatt for solar farm and agricultural. But for recently is we use like FIT as well for the year 2019 up to 2022. Most we focus heavily on the helping everyday household. The FIT rate for the household was 1.68 baht per unit from 2019-2021, and increased by 31% to 2.2 baht per unit from 2022 onwards. So right now, when you sell the electricity to the grid, it's about 2.2 baht per unit. So next slide is about solar PV rooftop. I think you have heard this program because regulatory commission had already announced this scheme encourage everyday citizens to install solar panel on their home and sell excess power back to the grid. As you can see from the box at the top right, our official total target was set at 90 megawatt peak to be supported through 2030. Look at how far the public feedbacks. The starting point is 2019. We kick off with just 2.64 megawatt peak of total installed capacity. The recent boom by the year 2024, the number approached to 91.04 megawatt peak, meaning officially hit and surpassed our target 6 years ahead of schedule. So this one is the massive goal is so incredible goal of the 3,000.3%. So this this scheme is implemented by the distributed utility MEA and PEA. You can see the percentage of each agency implement it. So the next slide is about the solar voting. Solar voting is mainly actually for the Ministry of Energy. They encourage EGET to implement it. They have, as you can see from the slide, they have already done to implement or execute the project in Silinthorn Dam and also Ubon Ratchathani Dam. So in addition, the EGET plan to develop a PV floating solar hybrid project at the Srinakharin Dam in Kanchanaburi Province with an installed capacity of 140 megawatt peak, which is scheduled to commence commercial operation in the year 2027. Further projects are also planned at 2 major dams, namely Bhumipol Dam in Tak Province with an installed capacity of 158 megawatt and Wachiralongkorn Dam in Kanchanaburi Province with an installed capacity of 50 megawatt, which are expected to be implemented shortly. Solar off-grid policy. So this one is maybe you don't heard about this before. While we have discussed major grid connected implemented, it is equally important to highlight how we look after our remote community. As shown in the slide, our department had a long history of driving solar off-grid policy to ensure no one is left behind. So this is our journey began back in the 1960s with localized projects like solar water pumping and also the charging station by the last 60th century. We scaled up the power rural government office. Then between 2003 up to 2007, we execute a massive household plus installed 203,000 solar home system across remote area of the country. Today, our footprint has reached an impressive total of over 4,000 megawatt peak instead of just residential power, this modern off-grid installation focus heavily on the social infrastructure that provide clean energy to Royal Initiative Project, Border Patrol, School, Sub-District Hospital, agricultural water pumping for the community, and national parks security base. So the next slide is about PV farm. The PV farm is we have the like a ground solar PV farm with the battery energy storage system. The target is around 1,000 megawatt. The SCOD is from year 2023 up to 2030. FIT rate is at 2.8331 baht per unit, and the supporting year is 25 years. So for the ground solar PV farm, this is without the battery. The target is around 5,000 megawatt SCOD in the same period year, and but the feed-in tariff rate is like lower than the previous one, so it's around 2.1679 baht per unit, and the support year is the same. It's 25 years. Next slide, please. This one is the scheme of the utility green tariff. The utility green tariff designed for the company wanting to buy 100% clean energy directly from the grid. Is split into two options. UGT1 use electricity from existing renewable energy plant. In it charge the normal retail rate plus a tiny premium of just 0.0994 baht per unit per kilowatt hour. UGT to use electricity from new and specified renewable energy source. This is divided into two rollout phase. Port A is from the year 2025 up to 2027, fixed at 4.5622 baht per kilowatt hour, and Port B 2028 up to 2030 is slightly adjusted to 4.5475 baht per kilowatt hour. So next is a solar direct PPA. This one is if we look at the solar direct PPA framework, which allow a clean energy producer to sell electricity directly to the consumer by passing traditional utility. This framework relies on 4 elements. Is it a private context? And also the long-term stability and direct connection, and also green certification. So the energy buyer can receive like a renewable energy certificate to equally certify that their electricity come from 100% renewable energy resources. Next slide, please. Solar tax rebate. This is already open for the household to join this scheme. The brand new intensive approved on March 3rd, 2026. The solar tax rebate program for home owner. The policy offers a massive financial incentive alongside a few specific rules. The benefit is home owner can claim a personal tax rebate of up to 200,000 baht against their solar rooftop installation cost. So the criteria is it strictly for Taiwan residential households, and and must match the name of the household electricity meter owner, and also it operates on a strict one person, one meter, one system limit. And the system must be a small scale on-grid system under 10 kilowatt peaks. And finally, it must be properly purchased, installed, and submit for connection approval with the distributed utility while this tax measure is actively in effect. This is implemented year from now and up to 2071. The community-based solar power generation project. So this one is we still on the way. It's still on the pipeline. We have not executed it yet. And we still have to discuss with the related agency. We hope that we can implement in this year. So it's for the community-based solar power generation project with the target of overall capacity of 1,500 megawatt. The project focus on local community benefit through specific criteria and condition. So each project, the criteria is the community should be had like the user consuming less than consuming the electricity less than 200 units per month. Each project is limited to a contracted capacity of 10 megawatt or less. Power is sold under 25-year non-firm feed-in tariff contract with the PA providing electricity cost reduction directly to the local community. So this is we still have to discuss. This is just the draft, but someone have passed to the public hearing already from the DEDE and also from Regulatory Commission ERC. So solar waste management. So as you see, the growth of the solar is very huge. So we have the government also have to concern about how to manage the disposal of the solar panel and also battery. So we have some we work with other organizations, but in Thailand actually we don't have the direct law to control on this measure, but we still have to discuss among the government agency because and how to set up the agency or how to control and how to track law. So this is something that we have to do, and also the regulation framework, how to approach on this point. Okay, the next is about reducing step for grid connecting permission. I think this one is on the private sector. They need the short period of time to ask for the permissions. So the case one for the self-consumption, after we discussed with the distributed utility, we got one is for the self-consumption approved. We will now be complete within 7 working days. And the case two is sale to the grid approved will be complete within 30 working days. So before this, for the sale to the grid, it around 75 days, and for the self-consumption is around 30 days. So hopefully that we can facilitate you more how to get the permission from the ERC. Then also one thing that I have to announce from now on, we after we promote the solar rooftop for the household, something we need to do is about the registrations for the installer, because we got many problems after we open for the some program about like the tech rebate. So this is not announced yet, but I would like to inform in advance that with the training, the installer have to go to the training and registrations, and the grid connection and rule have to be have the standard to be controlled. Okay, next slide, please. This one is the equipment standard, and in September, I think the Thai Industrial Standard Institute will announce the equipment standard for solar equipment and components. So the private sector have to be ready, and also the TISI had already prepared for on private sector to prepare on this point. But of investment intensive, I think I would like to, because now they stop to support the manufacturing scheme, so they have only solar PV system for the right hand side. Can you go to the next slide, because this one have the detail. I think all of you have known about this, the corporate income tax, and also the share import exemptions. This one and non-tax intensive. This is 3 category or 4 category for this one. Is I think all of you have known about this. Next slide, please. So this is to my last slide. I would like to review the 4 key takeaways regarding the Thailand solar development. Solar as a core energy source. Thailand National Energy Plan target over 50% of the new capacity from renewable energy, positioning solar power at the very corner of our decarbonization efforts. Evolving policy and intensive our transition from the adder system to feed-in tariff alongside the rollout of the utility green tariff, secure stable long-term support for 10 to 25 years to build strong investor confidence to keep this goal sustainable, establishing clear policy to end of life solar panel recycling and waste handling remaining a key focus area. Decentralization and community involvement. By pressing emphasis on decentralized generation, we foster community scale projects that broadens local participation and distributes economic and environmental benefit more effectively. Green integration challenge as solar penetration reached new high. It faced natural grid and capital constraint. Moving forward, investing in advanced forecasting and highly flexible infrastructure will be absolutely essential to safety managing the clean energy loss. So thank you so much. This is all I would like to say.
Thank you very much. Solar system is now the hot issue for everyone. So I hope that someday that we can install the solar cell in our house in low cost. So since now we're behind the schedule, so we can have only one quick questions from the audience or any comments. So obviously, it's a very clear presentations. Thank you very much. So please give our big hand to our speaker once again. Next, we have a joint presentations by Ms. Natashayan Jiwamawin and Mr. Kasidet Palabut from TÜV Süd, Thailand. They will present from clean energy to trust claim maximizing business values in the net zero era. Ms. Natashayan Jiwamawin is a senior manager, business assurance at TÜV Süd, Thailand. Her expertise spans management system, sustainability, and cybersecurity certification. And she has worked closely with organizations across the wide range of industries to strengthen governance, improve operational performance, and ensure compliance with international recognized standards. Mr. Kasidet Palabut is a sustainable auditor at TÜV Süd, Thailand, specializing in greenhouse gas qualifications and sustainability reporting. He supports organization through GSG verifications and environmental product declarations. His expertise helps organizations align with international standards while building credibility and trust with their stakeholders. May I now invite both speakers to deliver their presentations. Now the floor is yours. Thanks so much.
Thank you. Good morning, ladies and gentlemen. We are the representatives of TÜV Süd, Thailand. Actually, we are the certification body for the international certification body. We are the part of the sustainability program because actually for TÜV Süd, we also have one policy to go to the sustainability, even for our certification or international scheme service. All of international scheme will rely on the sustainability. Today, I and my team, Kasidit, will sharing for the popular standard and the trends of the standard in terms of the sustainability. Okay. Shall we start? This one cannot see on the slide, right? Okay, next slide, please. Next slide. First of all, I also would like to sharing about what we are doing right now for TÜV Süd Thailand. Next slide, please. For TÜV Süd, we already exist 150 years in the world. First, we start from Germany. We are not from the beginning, we are not a private company. We are forming from the industrial association from Germany that all of the manufacturer put the funding and we organize the institutes. This is the independent party to conduct the third party verification or review any kind of the safety, quality, or security. Next slide. Okay. For this activity in Thailand right now, in terms of the sustainability, we have total 3 facilities in Thailand. The first headquarters is located in San Park. This facility also supports the sustainability. As the director of the DEDE mentioned, we will have plan to verify the EV or solar equipment under Mo'ogo for the TC mark. For our facility also support the government policy because right now in terms of the home appliance or electronics product part. We have the facility, the labs in the Thailand Science Park. And the second one, we will have the facility in Nawanakon Industrial Estate. This facility will support in terms of the construction materials, firewall, or the facades, for example. And the third facility based in Chonburi, Amatanakon. This facility support for the EV battery testing. The capacity of the battery testing is around 400 kW. That is quite huge. I think we are the first one who have the facility for all the EV testing in Thailand. Next slide, please. Sorry. This is all the facility that we are support. Okay. For us, normally we do the certification, inspection, and also the product testing. And next slide. And also verification, validation and verification. For example, we call us as a VVB. In Thailand right now, we do the carbon footprint or ISO 1464, ISO 1467, carbon footprint product testing, and also the organization certification. For the next slide. Okay. This is all of the sustainability scheme that related to the sustainability. We have the IT security. This is also have many kind of the international standard like ISO 27000, ISO 20000. And right now, I think in Thailand, we already start for the AI certification, ISO 42000. We already have certified client in Thailand already for AI. I think in the future, in terms of the solar or the equipment, this will be managed by AI in the future. This ISO standard quite be the key move for us in the future. We also have our local resource to support this project for AI. For the other management system like ISO standard, I will pass very quickly. I will highlight for the sustainability. For sustainability, we also have some project related to the energy management like ISO 50000. We are working closely to the university. For example, like the energy efficiency project. We also try to supervise the manufacturer, or even we also do the lecturer for the Thailand University, because we think that if we build in the behavior from the new graduate and let them aware about the energy saving or energy management, when they are working to the manufacturer, it will be help all of us to have the mindset for the energy. For the next one, we also do the second party audit in many kind of the owner scheme related to the owner scheme, but they have many sustainability, for example, energy, climate change, net zero, or even for CBAM. Okay. This is other for the safety, automotive, and environmental management. Okay. For the next section, I will give the stage to my colleagues, Kun Kasidet, to maybe we have some sample of the international standard. He can sharing what kind of the trends of the standard in the near future. Yep. Thank you.
ครับก็สวัสดีครับ and I have to say my apologies to Dr. Ravi and other international in this room. I just got last notice of the changing the speaker, so in this section the rest of my section will conduct in Thai, but my presentation is in English, but I have tried my best to conduct. I'm so sorry. Okay. สำหรับเซสชันถัดไปนะครับของผมจะเป็นในส่วนของ Thailand Net Zero Pathway นะครับผมเซสชันนี้จะให้เห็นว่าในปัจจุบันนะครับผมประเทศไทยของเราเนี่ยครับผมได้มีการปรับตัวยังไงบ้างกับในส่วนของตัว Net Zero Pathway นะครับก็ทุกท่านในห้องนี้คงไม่มีใครไม่ทราบถึงสภาวะโลกร้อนของเราในปัจจุบันนะครับซึ่งมันส่งผลต่อสภาพภูมิอากาศหรือว่าปรากฏการณ์ทางธรรมชาติครับที่มันมีความถี่ที่มันรุนแรงขึ้นในส่วนของผลกระทบที่มันรุนแรงขึ้นนะครับผมเพราะฉะนั้นหลายๆประเทศนะครับผมก็ได้มีการจับมือกันในส่วนของตัวทำ Paris Agreement เนาะว่าเราจะจำกัดในส่วนของอุณหภูมิให้ไม่เกิน2 องศานะครับผมเพราะฉะนั้นถ้าlet's move back to 5-year goal at COP26 Thailand is commitment to reach carbon neutrality by 2050 and net zero by 2065 but as Dr. Munlika said this target have a change for now ในตอนนั้นถ้าเกิดย้อนกลับไปช่วง5 ปีที่แล้วครับผมก็จะมีบางคนถามว่าทำไมตอนนั้นถึงต้องเป็น2065ด้วยเพราะว่าถ้าลองดูในส่วนของอาเซียนเนาะก็จะเห็นว่าหลายประเทศเขาตั้งไว้ที่2050นะครับจะมีอินโดนีเซียอยู่ที่2060มีประเทศไทยนี่แหละที่ตั้งเนซิโร่ตอนนั้นอยู่ที่2065นะครับผมก็พี่เชื่อว่าหน่วยงานที่เกี่ยวข้องครับน่าจะทำการศึกษาแล้วว่าถ้าเกิดจะไปเซตให้มันเป็น2050เนี่ยมันอาจจะไวเกินไปด้วยตัวบริบทของประเทศไทยในตอนนั้นเนาะครับผมแต่ก็ข่าวดีครับช่วงพฤศจิกา last November 2025 we have already changed the net zero target to 2050 คือเราเลื่อนขึ้นมาเร็วขึ้นครับ15 ปีมันทำให้แผนต่างๆที่เราวางไว้ครับต้องมีการ revise เนาะมันก็เวลาน้อยขึ้นแล้วก็หน่วยงานที่เกี่ยวข้องน่าจะเห็นแล้วว่าถ้าเรายังคงเป้าหมายแบบเดิมอยู่ครับผมน่าจะส่งผลเสียอะไรบางอย่างมีข้อเสียนะครับอันนี้เป็นตารางครับผมเปรียบเทียบกับแผนตัวที่เราส่งไปให้กับ UNFCCC นะครับผมก็ปัจจุบันเราใช้ในส่วนของตัว NDC ปัจจุบันเราใช้ในส่วนของตัว NDC 3.0 อยู่นะครับผมก็สไลด์นั้นเนี้ยจะให้เห็นว่าพัฒนาการละกันครับในส่วนของตัว time frame ตัวเป้าหมายระยะสั้นแล้วก็เป้าหมายระยะยาวของเราครับผมซึ่งอย่างที่แจ้งไปเนาะเป้าหมายระยะยาวในปัจจุบันของเราเนี่ยเราจะเป็น Net Zero ในปี 2050 แล้วครับผมครับก็อย่างที่บอกไปว่าพอมันมีการปรับแผนขึ้นมาเนี่ยครับผมแผนเดิมที่ได้ถูกวางไว้ครับมันก็จะต้องถูกการรีไวซ์เนาะถ้าทางด้านขวามือของผมนะครับผมจะเป็นในส่วนของแผนปฏิบัติการปล่อยก๊าซเรือนกระจกหรือจริงๆตัวนี้เป็นเวอร์ชันเก่าซึ่งจะอะไรกับตัว NDC 2.0 ของเรานะครับตอนนี้น่าจะกำลังรีไวซ์อยู่แล้วก็ด้วยความที่ว่าประกาศช่วงพฤศจิกาปีที่แล้วนะครับอันนี้ก็กำลังรีไวซ์อยู่เช่นเดียวกับในส่วนของอีกแผนนึงที่สำคัญของเราก็คือตัว PDP ครับผมปัจจุบันเนี่ยแผนการกำลังผลิตไฟฟ้าของประเทศไทยตัวนี้ก็เป็นตัวเก่าอยู่ซึ่งจากงานสัมมนาล่าสุดช่วงมิถุนาที่ผ่านมาครับผมก็มีแววออกมาแล้วว่าน่าจะเสร็จภายในปีนี้แหละแต่ว่าคีย์สำคัญของเขาครับคือว่าตัว Clean Energy ครับสัดส่วนพลังงานสะอาดนะครับผมจะต้องมากกว่า 60% เดี๋ยวในส่วนของรายละเอียดเพิ่มเติมก็เดี๋ยวอาจจะต้องรอให้แผนออกมานะครับผมโอเคทีนี้เราจบในส่วนของตัวระดับประเทศไปแล้วครับผมเราลองมาดูระดับที่เล็กลงมาหน่อยละกันคือระดับของ Corporate เนาะเรามาดูกันว่า Corporate เนี่ยในประเทศไทยตอนนี้เขามีการวางแผนมีการปรับตัวยังไงนะครับผมสไลด์หน้าเนี่ยครับเป็นของ Net Zero Tracker นะครับเขาก็จะไปดูว่าประเทศที่ประเทศที่อยู่องค์กรที่อยู่ในประเทศไทยของเราครับผมได้มีการปรับตัวยังไงบ้างนะครับผมเขาก็จะเข้าไปดูว่าพวกเอกสาร Public ไม่ว่าจะเป็นรายงานต่างๆครับได้มีการจัดการได้มีการประกาศไว้อย่างไรหรือเปล่าซึ่งถ้าดูครับก็จะเห็นว่ามีหลายเซกเตอร์มากนะครับผมแต่ว่ามันก็ยังไม่ครอบคลุมของทางประเทศของบริษัทในประเทศเราเนาะก็จะมีในส่วนของ power generator ตัว material ตัว chemical ครับจะเห็นได้ว่าในแต่ละบริษัทครับก็จะคล้ายๆกับประเทศไทยก็คือจะตั้งเป้า Net Zero ไปที่2050เหมือนกันนะครับผมทีนี้ทางด้านขวามือครับผมที่เป็นในส่วนของสัญญาณไฟจราจรละกันมันจะแบ่งออกเป็น4 section ครับในส่วนของตัว detail plan reporting mechanism scope 3 coverage and carbon credit ครับแต่ละสีก็จะมีความแตกต่างกันออกไปยกตัวอย่างเช่นในส่วนของตัว detail plan นะครับจะเห็นว่าส่วนใหญ่บริษัทส่วนใหญ่ในประเทศไทยเป็นสีส้มเนาะมันสื่อถึงว่าโอเคคุณมีการตั้งเป้าหมายแล้วแหละแต่ว่าแผนระยะยาวเรามีแล้วแผนระยะสั้นเรามีแล้วแต่ว่าดีเทลในแต่ละปีมันอาจจะยังไม่ละเอียดอะไรอย่างเงี้ยครับแต่ว่าสิ่งที่ทุกคนทำได้ดีคือในส่วนของตัว reporting mechanism นะครับก็คือมีการรายงานแหละมีการรายงานทุกปีนะครับสโคป3 coverage ไหมก็ถ้าเป็นสีแดงก็คืออาจจะยังไม่ coverage ในสโคป3นะครับสีส้มหมายถึงว่า coverage แล้วแต่ก็อาจจะยังไม่ครบทุก category เนาะเพราะสโคป3อย่างที่เรารู้กันว่ามันมีหลาย category มากแล้วก็เป็นจุดที่ค่อนข้างลำบากสำหรับการเก็บข้อมูลแล้วก็การแปะประมวลผลออกมานะครับผมแล้วก็ในส่วนสุดท้ายในส่วนของตัวคาร์บอนเครดิตครับคาร์บอนเครดิตเนี่ยจะส่วนใหญ่ก็เป็นสีแดงนะครับก็จะบอกว่ามีแผนที่จะใช้แต่คือไม่มีว่าจะใช้เท่าไหร่จะจำกัดในส่วนของไหนอันนี้ก็คือยังไม่มีนะครับผมอันนี้ต่อไปเป็น4 step แล้วกันครับง่ายๆสำหรับ coverage ที่จะไปสู่ตัว net zero หรือตั้งเป้าการลดการเรือนกระจกในที่นี้นะครับสเต็ปแรกก็จะเป็นในส่วนของ GHG assessment คือก่อนที่เราจะตั้งเป้าหมายครับเราต้องทราบก่อนว่าcoverage ของเราในปัจจุบันนะครับปล่อยก๊าซเรือนกระจกอยู่ที่เท่าไหร่ต้องรู้ว่าแหล่งปล่อยไหนเป็นแหล่งปล่อยสูงสุดของบริษัทเพราะว่าแต่ละบริษัทมี activity ที่มันไม่เหมือนกันมีการดำเนินงานที่มันไม่เหมือนกันนะครับก็ต้องทราบก่อนทีนี้พอทราบแล้วครับก็จะตั้งเป็นบางบริษัทก็ตั้งเป็นจะใช้สิ่งนั้นเป็นเบสเยียร์เนาะเป็นเบสรายเยียร์หรือว่าปีฐานนั่นเองพอเราตั้งปีฐานเสร็จแล้วปุ๊บเรารู้แล้วว่าจุดไหนเป็นการปล่อยก๊าซเรือนกระจกสูงสุดก็ไปที่ target setting and strategy นะครับผมก็คือมีการตั้งเป้าหมายแหละบางบริษัทก็อาจจะตั้งอะไรกับในส่วนของตัวประเทศไทยนะครับที่ปี 2050แล้วก็มีการทำระดับเป้าหมายระยะสั้นออกมาอะไรอย่างเงี้ยครับอีกเรื่องนึงที่สำคัญในส่วนของ target setting คือในเรื่องของการ allocate เงินครับแต่ละแหล่งปล่อยก๊าซเรือนกระจกอะครับผมเรารู้แหละว่าบริษัทของเราอ่ะมันมีแหล่งปล่อยก๊าซเรือนกระจกมาจากไหนบางบริษัทอาจจะมาจากไฟฟ้าแต่คำถามคือว่าเทคโนโลยีวันนี้ครับผมมันเพียงพอแล้วมันเข้าถึงได้แล้วหรือยังแล้วก็การเงินมันเป็นยังไงหมายถึงว่ามันสมเหตุสมผลไหมบางอย่างเราปล่อยเยอะจริงแต่ว่ามันยังไม่มีเทคโนโลยีในปัจจุบันที่สามารถมาตอบโจทย์ได้อะไรครับก็ต้อง prioritize ลำดับของมันพอเรารู้แล้วว่าเราจะทำอะไรก็ในส่วนของสิ่งที่สำคัญก็คือถัดมาคือการลงมือทำครับผมซึ่งคิดว่าหลายๆบริษัทที่มาเข้าร่วมในวันนี้ครับน่าจะได้มีโอกาสไปดูในส่วนของตัวงานเทคโนโลยีข้างล่างนะครับว่าโอเคในปัจจุบันเนี่ยเทคโนโลยีอะไรมันตอบโจทย์กับบริษัทเราในส่วนของพวกเรื่อง energy efficient หรือว่าในส่วนของพวก renewable energy นะครับผมและสุดท้ายแล้วครับผมก็คือการ monitoring and reporting ครับเราก็ต้องดูว่าเงินที่เราลงไปเนี่ยครับผมมันมีประสิทธิภาพมากน้อยแค่ไหนมันลดได้จริงไหมจากนั้นเราก็จะมีการรายงานสู่หลายๆบริษัทก็จะรายงานสู่ Public ครับซึ่งอาจจะต้องมีการใช้ Third Party Assurance เพื่อความน่าเชื่อถือแล้วกันครับผมต่อไปจะเห็นว่าในแต่ละขั้นตอนพวกนี้มันคือคอร์สทั้งนั้นครับไม่ว่าจะเป็นในส่วนของ GHG assessment เนาะบางบริษัทอะครับผมไม่ถ้าสมมุติคนในองค์กรนะครับยังไม่ได้มีความรู้ก็ต้องส่งไปอบรมนี่ก็คอร์สหรือเขาจะใช้ consultant ก็คอร์สเหมือนกันในทางกลับกันนะครับผมimplementation เนี่ยน่าจะเป็นคอร์สที่เยอะที่สุดเพราะว่ามันเป็นการปรับเปลี่ยนในส่วนของตัวเทคโนโลยีเนาะอะไรอย่างเงี้ยครับแล้วก็ขั้นตอนสุดท้ายหรือแม้กระทั่งการใช้ Third Party Assurance นี้ก็เป็นคอร์สเหมือนกันครับทีเนี้ยหน้าถัดไปจะเป็นสิ่งที่ผมว่าแล้วข้อดีของมันคืออะไรทำไมบริษัทต้องทำนะครับผมข้อแรกก็คือ cost reduction แน่นอนถ้าเรามองในช็อตเทอมครับมันคือเงินทั้งนั้นแหละแต่ว่าเมื่อถึงจุดคุ้มทุนของมันแล้วครับอันนี้ก็จะช่วยลดค่าใช้จ่ายต่างๆในองค์กรได้เช่นเดียวกับการ mitigate the risk ครับผมก็เราไม่รู้หรอกนะว่าในอนาคตค่าพลังงานของเราหรือค่าใช้จ่ายในด้านนี้ครับมันจะสูงขนาดไหนซึ่งมันก็สามารถช่วยลดตรงนี้ได้อีกอันนึงในเรื่องของการแข่งขันทางธุรกิจครับก็คือเรารักษาฐานลูกค้าเดิมไว้เช่นในปัจจุบันนะครับถ้าบริษัทของคุณส่งสินค้าไปให้ทางตัว EU ก็ทราบกันดีว่าถ้าเกิดบริษัทอยู่ในเซกเตอร์ที่เป็นพวกเหล็กอลูมิเนียมอย่างเงี้ยก็จะรู้ว่าตอนนี้เรื่อง CBAM ก็มาแล้วนะครับผมแล้วก็ถ้าสมมติไม่มีการรายงานค่าต่างๆก็จะมีคอสต่างๆตามมาหรือว่าไม่สามารถเอาไปขายได้นะครับผมแล้วก็อีกเรื่องนึงเป็นของ Green Finance ครับการเข้าถึงแหล่งเงินทุนสีเขียวใหม่ๆแล้วก็อัตราดอกเบี้ยที่มันลดลงตรงนี้ถ้าเกิดบริษัททำก็สามารถเข้าถึงตรงนี้ได้ครับแล้วก็สุดท้ายในส่วนของตัว strategic alignment นะครับผมก็คือบางบริษัทมีการตั้งเป้าหมายแหละแต่ว่าคำถามคือว่าแล้วผลการดำเนินงานล่ะถ้าเกิดไม่มีการทำไม่มีอะไรที่มันคืบหน้าเลยstakeholder ก็อาจจะมองว่ามันเป็นการ green washing ได้ซึ่งส่งผลเสียต่อภาพลักษณ์ขององค์กรครับผมประมาณนี้สเต็ปถัดไปก็อย่างที่แจ้งกันอันนี้เป็นช่องทางการรายงานนะครับหลายๆคนหลังจากที่ลงไปแล้วมีการรีพอร์ตแล้วเขาก็จะรีพอร์ตตามช่องทางเนี่ยครับผมก็ถ้าเป็นบริษัทที่อยู่ในตลาดหลักทรัพย์ก็จะต้องรายงานบางส่วนอยู่ในวันรีพอร์ตนะครับผมแล้วก็หรือบางบริษัทบอกว่าเราไม่อยากเอาไปรวมกับงบการเงินมันเนื้อหามันเยอะก็จะแยกในส่วนของ sustainability report ออกมาหรือว่ารายงานความยั่งยืนหรือว่าบางบริษัทครับตัวอย่างอันนี้เป็นแบบฟอร์มของทาง TGO เนาะก็คือว่าถ้าเขาจะประเมินการปล่อยก๊าซเรือนกระจกหรือขอการรับรองกับ TGO เขาก็ต้องมีการทำแบบฟอร์มนี้ซึ่งบางบริษัทก็จะรายงานกันนะครับผมต่อมาคำถามคือพอรายงานแล้วครับคำถามที่สำคัญต่อมาคือแล้วแน่นอนแหละครับในบริษัทของเราเนาะก่อนที่จะรายงานอะไรออกมามันก็ต้องมี internal review มี management review ก่อนที่จะรายงานคำถามประมาณในองค์กรนะคุณเชื่อแหละว่า ข้อมูลที่คุณปล่อยออกมามันถูกแต่คำถามคือว่าในมุมมองของ external stakeholder ล่ะทำไมนักลงทุนทำไมผู้ถือหุ้นทำไมคู่ค้าทำไมลูกค้าของเราต้องเชื่อข้อมูลของคุณอะไรอย่างเงี้ยครับซึ่งในปัจจุบันเนี่ยครับผมมันมีในเรื่องของ green washing หรือการฟอกเขียวมากอันนี้ระหว่างทำสไลด์ผมก็ไปเจอในส่วนของตัวรายงานตัวนี้นะครับผมเป็นในส่วนของโครงการศึกษาการฟอกเขียวของรัฐวิสาหกิจ10แห่งของประเทศไทยเนาะนำเสนอโดยสภาองค์กรของผู้บริโภคแล้วก็จัดทำโดยป่าสาระประมาณ164หน้ายังอ่านไม่จบเหมือนกันครับแต่ว่าเป็นตัวอย่างที่ค่อนข้างน่าสนใจมากครับผมเชื่อว่าหลายๆบริษัทนะครับไม่ได้อยากทำในส่วนของตัวการ green washing หรอกหรือว่าในบางครั้งเขาไม่รู้ว่าสิ่งที่เขานำเสนอออกไปเนี่ยมันถูกจัดอยู่ใน green washing เหมือนกันประมาณนี้ครับทีนี้มาสู่ในส่วนของเซสชันสุดท้ายแล้วครับผมในส่วนของ from data to trust claim นะครับ the role of third party assurance ก็จะมาดูว่าเราจะกำจัดในส่วนของเราจะช่วยลดในส่วนของเรื่อง green washing ได้ยังไง third party ก็จะเข้ามามีส่วนในพาร์ทนี้ค่อนข้างสูงครับผมอันนี้เป็นถามว่าทำไมคอมพานีเนี่ยครับทำไมต้องทำ third party assurance ทำไมต้องจ้างหน่วยงานภายนอกเข้ามาข้อแรกเลยมันเรื่องของ confidence ครับผมหน่วยงานภายนอกเป็นหน่วยงานที่ไม่ขึ้นกับองค์กรคือมีความเป็นอิสระและการใช้อย่างนี้ครับผมเพราะฉะนั้นนะครับมันก็จะช่วยเพิ่มความน่าเชื่อถือข้อมูลที่ทางบริษัทรายงานออกมานะครับช่วยเพิ่มความน่าเชื่อถือต่อนักลงทุนหรือต่อ stakeholder อื่นๆของเรานะครับผมต่อมาในส่วนของตัว market access นะครับผมก็เป็นการทำตามความต้องการของลูกค้าแล้วก็หน่วยงานกำกับแล้วกันครับผมก็ลูกค้าบางคนก็จะบอกว่าข้อมูลคุณตรวจแล้วหรือยังเพราะเราต้องใช้ข้อมูลของคุณเราไปใช้ในการคำนวณของเราต่อนะอะไรประมาณนี้ครับหรือว่า regulation ของเราในปัจจุบันอย่างเงี้ยครับถ้าเกิดสมมุติพรบตัว draft ออกมาพรบclimate action ออกมาอย่างเงี้ยครับถ้าบริษัทของคุณอยู่ในกลุ่มที่จะต้องรายงานก็จะต้องมีการทวนสอบด้วยอะไรประมาณนี้ครับและข้อสุดท้ายครับก็เชื่อมโยงกับสไลด์ในเรื่องของ green washing เนาะอย่างแรกเลยมัน reduce ในเรื่องของ leak ในเรื่องของความไม่ถูกต้องของข้อมูลทางเราก็ทาง third party assurance เนี่ยครับก็จะเข้าไปช่วยสกรีมด้วยอะไรที่มันไม่ถูกต้องก็จะช่วยดูครับแล้วก็ในเรื่องของ minimize green washing concern นะครับผมก็ช่วยลดได้เพราะว่าตัวอย่าง case study ก็คือลูกค้าของเราบางคนนะครับหลังจากที่เขาขอการรับรองของเราเสร็จแล้วเขาก็จะส่งมันก็ต้องมีการ marketing เนาะซึ่งเขาก็จะส่งบทความมาให้เราดูว่าแบบเนี้ยมันโอเคไหมมัน over claim หรือเปล่าอะไรประมาณนี้ครับอันนี้ก่อนที่จะออดิเตอร์หรือว่าผู้ตรวจเขาจะดูครับผมเขาจะดูอยู่หลักๆ2เรื่องด้วยกันครับเรื่องแรกคือเรื่องของเคลมคือลูกค้าจะเคลมอะไรซึ่งในปัจจุบันมันมีเยอะมากครับไม่ว่าจะเป็นในส่วนของตัวเลขการปล่อยก๊าซเรือนกระจกขององค์กรตัวเลขการปล่อยก๊าซเรือนกระจกของผลิตภัณฑ์หรือแม้กระทั่งเนื้อหาใน sustainability report อะไรอย่างเงี้ยครับผมก็ต้องรู้ก่อนว่าลูกค้าจะเคลมอะไรต่อมาก็ต้องรู้ในเรื่องก็ต้องรู้ในเรื่องของตัว applicable standard and criteria ก็ต้องรู้ว่าเรารู้แล้วแหละว่าลูกค้าจะเคลมอะไรแล้วลูกค้าจะเคลมกับตัวสแตนดาร์ดตัวไหนล่ะซึ่งในปัจจุบันมันมีเยอะมากถ้ายังเป็นของ2ตัวแรกครับ CFO กับ CFP อย่างเงี้ยอันนี้คือของ TGO เนาะของเราถ้าเป็นของต่างประเทศหน่อยก็จะเป็น ISO 14064-1 ISO 14067 GHG Protocol หรือแม้กระทั่ง EPD Environment Product Declaration นะครับจริงๆในประเทศไทยตอนนี้ก็มี EPD Thailand ครับผมแต่ว่าสิ่งที่ทูบซูดเราโฟกัสอยู่เมนหลักจะเป็น ISO 14064กับ EPD International ครับผมอันนี้ก็ขอยกตัวอย่างในส่วนของสเต็ปละกันนะครับในส่วนของกระบวนการ verification process นะครับกระบวนการตรวจซึ่งที่ผมยกมามันคือตัว 14064-1 เนาะหรือ Carbon Footprint for Organization มันไม่ได้หนีกันไปมากครับการตรวจนะครับผมหลักแรกเราต้องจัด kick off meeting กับลูกค้าก่อนก็ต้องดูครับว่าลูกค้าจะ report อะไร boundary ของลูกค้าเป็นยังไงทีนี้ก็ไปในส่วนของตัว planning นะครับผมก็อันนี้เป็น internal ของทางผู้ตรวจเขาก็จะดูว่าข้อมูลของลูกค้าหรือบริษัทของลูกค้ามีความเสี่ยงอะไรนะครับผมเขาจะดูตรงนี้ต่อมาก็จะไปลงออดิตและก็จะไปออนไซต์ของลูกค้าดูแหล่งปล่อยก๊าซเรือนกระจกดูข้อมูลลูกค้านะครับผมสเต็ปที่4ก็จะเป็นการออกในส่วนของตัวรีพอร์ตให้กับลูกค้าว่าสิ่งนี้คือสิ่งที่เราพบเจอนะมัน non conformity ตรงนี้นะอะไรคือเป็น finding อะไรคือ clarification ที่ทางเราอยากจะขอเพิ่มอะไรอย่างเงี้ยครับผมอะไรคือ area for improvement ที่ให้ลูกค้าสามารถเอาไปปรับใช้ในปีหน้าได้อะไรประมาณนี้ครับแล้วก็อันสุดท้ายนะครับก็คือในส่วนของการออกในส่วนของ statement ให้กับลูกค้าอันนี้ก็เป็นตัวอย่างคร่าวๆครับผมตัว action listทางด้านขวามือครับจะเป็นเอกสารที่เราออกให้กับลูกค้าว่าหลังจากที่เราไปออนไซต์มาตรวจแล้วเนี่ยเราเจออะไรก็มี1 2 3 4ลูกค้าก็ต้องแก้มาถ้าลูกค้าแก้จบปุ๊บก็จะได้อีก2อย่าง2เอกสารสุดท้ายนั่นคือตัว statement กับในส่วนของตัว report นะครับที่จะบอกว่าโอเคการปล่อยการเลือกจากขององค์กรในแต่ละสโคปเป็นยังไงรายละเอียดก็จะเจอในตัว report นะครับก็จบครับผมในส่วนของ key takeaway ของพี่มองว่าพี่อยากฝากไว้ประโยคนึงแล้วกันครับว่าจริงๆแล้วครับ ในปัจจุบันหลายๆองค์กรนะครับผมก็จะมีการทำในส่วนของตัว GHG assessment อยู่แล้วแหละซึ่งก็จะมีการประชาสัมพันธ์กันแต่ว่าสิ่งนั้นเป็นแค่จุดเริ่มต้นครับเพราะว่าสิ่งที่สำคัญกว่าคือตัวผลการดำเนินงานของเรามากกว่าว่าเราจะทำยังไงให้เราจะลดก๊าซเรือนกระจกยังไงให้สอดคล้องกับตัวเป้าหมายที่เรากำหนดไว้เพราะฉะนั้น GHG assessment เป็นแค่จุดเริ่มต้นครับผมก็ประมาณนี้ครับ
Thank you very much ขอบคุณมากค่ะ Now we have some time for question, 1 or 2 questions or any comments to suit. Okay.
I'm Sirikit from NIMT Thailand. Okay, thank you so much for your fruitful presentations. And well, yesterday I just got information from Professor Fernandes that to also verify and certify the system that operate in high pressure as well as combustions for safeties. I would like to know because we are trying to establish one system like this at NIMT. So do you also certify this in Thailand and give them some certifications and?
Let me answer this question. Actually, I think we have some facility in Thailand, but not all the parameter. Some we also need the facility in ASEAN. But however, if you would like to have the cooperation, even not for the facility, the resource, we pull the resource in ASEAN. If the government or the manufacturer would like us to support for this project, I think all of our tube people are running around. We can support. Thank you.
Thank you. That will be very nice to cooperate inside our country and in the area. Thank you so much.
Thank you very much. That's what we want to hear because now we're gathering together, so we can have another collaborations among each other about this incident. Because as the global warming right now is very, very hard, difficult for people in European countries.
May I have additional some message? Actually, for tube suit, we also support manufacturer in terms of if you would like to expand your business in other country. We have one division called Global Market Access. We have all of the people who have the expertise like a law and regulation in other country. Normally for the exporter, when you export your product to other country, at least you should know about what kind of the regulation or what kind of the standard. You should be prepared yourself before you export the product. We have our team to support. Even you are not have any kind of business, we are willing to provide the knowledge. You also can call us. This is one of the compliment we can provide to the manufacturer. Thank you.
Thank you very much. Another questions? Okay.
Thank you very much for presentations. Quite interesting for us. One question I would like to know, as we mentioned about the testing that TC going to compulsory that everyone in the country had to test on that. I would like to know your opinion from your international opinion about this. Whether the capacity that tube should have in Thailand, whether is enough to accommodate the need in the short period of time, and whether you have any recommendation for us in how to improve this way to make the control quality in the sustainable way.
Yeah. Actually, right now we also get the accredited by TC, but not the EV equipment yet. But for example, like automotive part or the metals or kind of we call the more ongoing product, we already conduct the audit under TC. As we found all of the problems, because sometimes even our auditor also go to China to audit at the Chinese factory because all of the Chinese manufacturer, they like to export their product to Thailand, and we also conduct the audit there. There is still have some deviation compared for the TC mark and international standard. But however, for us, we also can can clarify the gap. Even sometimes when we have I think TC also arranged a meeting to get the public hearing. How is the standard and how is the barrier or is the problem when the auditor go to the audit? We also can contribute the contents because we have the experience both for the national standard and international standard. It's not just only because some study or some case, we also learn from our colleagues for example, in Brazil or in US. Because in terms of the certification body, we are not accredited only one accreditation body. We also can compare with many kinds of the accreditation all over the world. So this is one thing that we also can support, even to feedback to our government agency. Thank you. I hope this answers your question.
Thank you very much for the fruitful discussion. So let's join me to give a big hand to our speakers. It's now my great pleasure to introduce our distinguished speaker, Professor Dr. Ravi Fernandes. Professor Fernandes is head of departments of physical chemistry at National Metrology Institutes of Federal Republics of Germany, or we call PTB, and professor at the Technical University of Braunschweig. Widely recognized for his contribution to energy metrology, his research spanned combustions, hydrogen, LNG, and sustainable aviation fuel. He has led major European metrology initiatives and currently serves as chair of IMECO Technical Committee of Energy Measurements, fostering international collaboration in trust measurements that support energy efficiency, sustainability, and the global energy transition. Today, he will deliver a presentation entitled Measurement for Emerging Energy System, EU Experience in Hydrogen Energies and CCUS. Ladies and gentlemen, please join me in welcoming Dr. Ravi Fernandes. Professor, the floor is yours.
So a very warm good morning to all of you, and it's a pleasure and honor for me to be here in Thailand for the first time, and also looking forward to discuss a little bit on the European Union perspective on the energy scenario. I think you'll have set a perfect stage for me, from policy to certification, and now I will take you to the laboratory where the real measurements happen, and basically a foundation for trust, building trust. This year we had the theme of metrology, building trust in policy making, in decision making, and I think what lot is happening in the laboratories, and metrology is one of the strongest pillar which is helping to build this trust and support innovation, support certification. We also work with TÜV Süd. I will come to one of those slides where we work on ammonia certification as a fuel of the future. Of course, I could talk a lot about EV and wind energy. We are doing a lot there, but I specifically chose this topic on hydrogen and CO2 because I feel at home here on this topic. But it's a lot happening also in Germany and in Europe. So let me see how this works. There you go. So those of you who do not know PTB, is a National Metrology Institute, just like NIMT, but we are 140 years old now, one of the oldest metrology institutes. And we are located at 3 places, one in Berlin and two spots in Berlin actually, and one in Braunschweig. 2,600 employees working on very different topics. You can see the departments here, and one of the tasks is also, dissemination of units and also harmonization across borders, which is very important. Global standards to develop that, and also capacity building, knowledge transfer is one of the important aspects. So supporting the industry. But I will not talk about all these. Let me take you to the new advancements which are happening in the energy stream, and why I want to really bring hydrogen as a topic. Germany is a net importer of energy. If you look at it, Germany cannot produce much of its energy. It's coming from outside. But this also means that we have to deal with trade. And trade means fair billing, right? So it's also important. Germany has been a technology provider, and this technology can also go to other countries. So it's important that we work on these energy carriers even though we do not have our own sources of energy. Of course, Germany is producing hydrogen, but not enough to support. Yeah, so a lot will be import in the future. Sorry, I think I'm going in the other way. Is that the one? Okay, there you go. So, and one of the important goals as the world is moving to renewable energy, the future will be renewable, the future will be sustainable, and the UN has already set up the Sustainable Development Goals. And I would pick up 2 Sustainable Development Goals. One is the Sustainable Goals 17. Did I put it off? Sorry. No. 7 and 13. So one is the climate action and the other is affordable energy. And energy and environment are connected with each other, right? So when you use new energy carriers, you'll also produce different types of emissions. So we need to also see what type of new emissions are coming. That is one of the aspects, I hope, yeah. And EU climate action has been very stringent, much stringent than here. By 2030, we have to be fit for 55 package. That means from the 1990 goals of the emission, we have to reduce 55% of these emissions. So, and it's by 2030. So it's a very stringent goals. I'm not sure whether we will achieve this ambitious task, but there are a lot of steps towards this. So why hydrogen? And hydrogen is a very important bridging element between photovoltaic, wind, until sustainable aviation fuels, for example, right? So you have excess electricity. From excess electricity, you produce, through electrolysis, green hydrogen. And hydrogen, along with nitrogen, you can produce ammonia, or hydrogen with CO2, carbon dioxide, you can produce methanol. So hydrogen is basically the linking, a sort of a storage medium for excess electricity, if you would like to see it that way. Okay? So a building block, but of course brings a lot of challenges to be implemented in the market. And I will not discuss all the challenges, but definitely the challenges which are more related to metrology. And I am picking up one of the ISO standards here, and one of the most important hydrogen metrology need is the hydrogen quality. Okay, so Germany is already injecting hydrogen in the natural gas grid. Now, the problem is the energy value of hydrogen is much lower than methane. In the natural gas grid, methane with high purity has a higher calorific value. But now if you inject hydrogen in this, the calorific value of this admixture is going down. Right? So now, since it is traded, we need to know the calorific value very well. Initially, hydrogen was measured, the calorific value was measured by a calorimeter. Nowadays, you do not use a calorimeter, you use a gas chromatograph, because from the composition, you can actually calculate the calorific value. What is more important also is the pressure, temperature, density. Leak detection, because hydrogen is not one of the safest molecules, because when you pressurize it at very high pressures, you have liquid hydrogen, And it's a very explosive type of a molecule. So safety becomes an issue. If it is leaked outside, you have issues with hydrogen. So metrology has to form the basis for accurate measurements for these quantities: pressure, temperature, composition, leakage, to ensure that the society also accepts it. You might know Germany had a lot of nuclear reactors before, but now there are no nuclear reactors anymore. And you would wonder why. Because after the Fukushima disaster, every nuclear reactor was stopped. Now just imagine something happens with hydrogen. There will be no hydrogen talk anymore from Germany. So this is how, because we have to take the society along with us. And for that, we need to be well informed. So that is why the trust comes from real, reliable metrological data. A lot of standards, of course, the hydrogen, the purity of the hydrogen is different for different applications. If you use it for the fuel cells, you have to have more than 99% hydrogen. But the question is, what is that 1%? If that 1% has some contaminants which can poison the fuel cell or the catalyst, then the equipment is also dead. So this is where, again, metrology has to play a very critical role to even quantify this 1% very, very accurately. So accuracy, reliability, precision, and the trust for policy making. This is, and again, comparison. We have to compare and capacity building for those organizations which do not have these competences yet, but we will build most probably in the future. The other part I talked about was CO2, right? So I saw from TÜV Süd the nice plot of the CO2 emissions going high, global warming happening. Of course, industrialization also means that you will have a lot of CO2 emissions in the future. So either we go green and stop the CO2 emissions or remove the CO2 emissions. And I think removing of CO2 emissions will be the future because we have already put too much CO2 in the atmosphere at the moment. Now the question is, how do we capture this CO2? This was not a topic in Germany before. In the Europe, yes, but not in Germany. So capturing CO2 means you have to use some sort of chemicals like amines. And there is a lot of trace ammonia in this capturing process. So the CO2 in the future will be used as a feedstock for synthetic fuels. So if you want to produce methanol from hydrogen, then you have to use CO2. But the question is, how pure is the CO2? Again, a question for the CO2 quality. CO2 is not as dangerous as hydrogen, but CO2 brings other problems. And one of the biggest problems, and I will come to that next. So the other aspect is we have to also provide calibration and traceability for all these parameters. And we have the legal foundation from legal metrology such as OEML. We have the standardization organization, and these standards have to be harmonized. But as I said, I will come to the CO2 topic later, but let me brief you some of the projects which we are currently doing. Some of the projects which we are doing in the European Union with the support of Euromet. And I just sampled 3 projects for you, from the grid to the wheel. The first is the decarb project from the gas grid. So right now you can inject hydrogen in the gas grid. Up to 20% is admissible. But we also have to know exactly how much hydrogen is there, because I said the energy value is directly proportional to the hydrogen concentration. So higher the hydrogen, lower is the energy value. So we have to know what we pay for what we get, right? So the first project is exactly about the blending of hydrogen in natural gas. Now you have a blend. The second project is on standardization of hydrogen fuel at the dispensing station. And for this, you need a very good quality control. You have to know what is the impurity in the system, whether the sampling is done right? And the third project is on hydrogen vehicles, because hydrogen might not be directly coming to the fuel station as hydrogen. It might come as ammonia. It might also come as a liquid organic hydrogen carrier. Now, how do I know how much hydrogen is really delivered to the customer? Because it is not in the form of hydrogen. It has to be cracked back to hydrogen. So is the cracking 100% so that you exactly know? If the liquid organic hydrogen carrier is sort of a molecule where hydrogen is loaded on that molecule. And so when it is at the pump, you use a catalytic system to again dissolve that hydrogen back to the vehicle. So unless you know how much hydrogen is really delivered, you cannot really do the fair billing. And this is one of the projects which looks at the online monitoring, quality monitoring, and also investigating the properties. CO2 challenges are even more. Although I said safety is not an issue with CO2, but CO2 is a very crazy molecule because it has its supercritical nature. So at very low temperatures, it can be liquid, and something called a critical point is at 30 degrees, because at 30 degrees, it can exist as a liquid as well as a gas. So, and the question is now you have multi-phase flow. It's not just a liquid, it's not a gas, it's somewhere in between, completely different characteristics of CO2. Now the question is, how do you measure the flow of CO2? How do you measure also the purity of CO2? So CO2 is bringing a lot of new challenges to metrology. But if they are not well determined, we also have a problem with trade in the future. So fluid properties is important, large variations in density, and if there are impurities in the CO2, then the whole critical temperature shifts to different temperatures and pressures. So now you have to know the temperature, you have to know the pressure, you have to also know the purity. But if the purity is not right, then you get completely different conditions. Okay? So this is what we in scientific research, in scientific metrology are dealing with in Europe. There are a couple of CCUS projects going on. This is one of them to support the capture, utilization, and storage. As I said, flow metrology will be very important. Gas composition. We are also working on waste to energy projects from waste thermal power plants, from biomass plants, and trying to capture the CO2 on site. And we have to know how pure this CO2 is. We have to quantify the impurities there, and only then it can be stored underground. It's not just about the utilization, even storage underground. You have to know the purity of CO2 because there are standards for this, and metrology is basically assisting these standards. Good. So these are some of the projects. I'm coming to some of the standards. This is one of the ISO standards for hydrogen quality. You can see that you need to quantify the impurities very well. This is a huge challenge for metrology. And this is where I'm talking about trace impurities in parts per million level. And most of the traditional equipment cannot get there yet. And we have to really see that metrology is advancing in the future in this direction. Same for CO2. CO2 for both upstream and downstream. There are different requirements for the capture of CO2, at the same time using CO2 for utilization. Here I have already put up, you have ammonia, you have BTEX, you have hydrogen sulfide, so a lot of chemical components that need to be quantified very well. And of course, this is how our traceability looks like. You have a lot of providers like Linde Air Quality. They work with secondary standards or reference standards. The National Metrology Institutes have the primary reference standards, so we have to be traceable to the national standard. And until now, these gases are done in cylinders, so you have to do gravimetrically. You weigh each component and make it. But the question always is whether what we put in is also what comes out later, because it also the shelf life, there could be reactions in the system. So many primary reference standards are very stable, but not maybe everything. And so this has to be analyzed. So we have analytical methods to verify that. So verification becomes a very important part in energy metrology. And so what I just said is we have these conventional methods. We put it in a cylinder, and we do the analysis. They are traceable to the SI, everything good. But if you have reactive systems, and one good example is ozone in systems, is very unstable molecule. So you cannot store it in cylinders. And for such systems, we are trying to go to optical methods using spectroscopy. And this will be most probably the future. Instead of a gas cylinder, now we are thinking of using an absorption spectrometer that could be used as a direct optical gas standard for gas calibration in the future. So this is the next generation, and so I think metrology has to move in this direction. This is something called molecular fingerprinting. Just like when you go in an immigration office, you have to put your fingers and you know who you are. Just like that, you have molecular fingerprinting for all different molecules. You pick up some chemistry of that. I mean, a line of this, absorption line, this works on something called the Lambert-Beer law, where absorption is used directly to verify the composition. So we did this for ammonia. The limit of the standard was 1 ppm, and we can really do up to billion parts per billion, so 0.8 parts per billion. So we are already reaching these targets with this new advanced metrology, and we hope to do it also for other impurities. This is like formaldehyde in CO2. Purity, as I said, is very important. So we can use these techniques. Look this at one of these stretching molecules. Sorry, I think it's gone back. Or maybe it's time up. I'm just done. Just one slide, I think. There you go. Yes, so we are developing completely these instruments at the moment, and also trying to not just quantify composition, molecules, but using the same technique, using the same technique to look at other parameters. If you see this equation, you don't have to understand that. There is something called pressure and temperature also in the same equation. So if you know the spectroscopic data very well, which is SI traceable, you can also look at pressure and temperature directly in a system. And this is also green time shipping. This is a project which we are also working with TÜV Süd, taking onboard optical gas standards, because the shipping industry cannot always transport these big cylinders across their fleet. And in the future, they will have to do the reporting directly to the authority. This is connecting the digital world with the optical gas standards. You can see here, we have an optical gas standards on board, and they can interact with each other for different fleet systems, and then this will be directly reported to the concerned authorities. This is for emission verification. It requires the MRV monitoring and verification, reporting and verification. This will be automatically done in the future digitally. And of course, as I said, the dynamic pressure and temperature, which I was talking about. So this is a project together with the shipping industries to have laser-based spectroscopy for dynamic pressure, dynamic temperature, and also chemical species, all in one measurement setup. Okay, so this is the future we think that we will work on, and using the spectra, we have something called a shock tube. We can dynamically produce pressure and temperature. This is something which we want to work with NIMT in the future, to have something like a shock tube. And using this shock tube, you can use a spectroscopy, as I said, to look at pressure, temperature, and chemical species. We have done this, and we are working with RISE in Sweden to have the next CMC, and we'll be happy to work also in Asia, so that we have these new measurement techniques for onboard system also, which will help the maritime industry in a big way. Yeah, this is the last slide of the ammonia as the energy carrier. You can see also tube suit here. A lot of questions open there on reference materials. Impurities. Ammonia is a sticky molecule, so it sticks up on the walls. So we cannot use conventional methods. You need gas and liquid flow measurements. You have to know about the leakage because it's a toxic substance. And of course, the emission measurements, because we have completely new emissions like this N2O, nitrous oxide, if you use ammonia as a fuel of the future. So, yeah, quality of ammonia is important, emissions are important, and metrology is doing its part. And one of the most important challenges for metrology is in real system under harsh environments. And this is under combustion systems. We work with automotive industry, how to measure under very changing harsh temperatures and pressures to have traceable measurements. And with the help of AI, I think we will be able to do it. And we have the first results to measure all these quantities under harsh environments in a very accurate way. So the scenario for metrology is changing in energy. I have just shown you a few examples, but there's lots other to do. And I'm looking forward to this new dynamic world of metrology, and looking forward maybe in the next time to show you some of the results. If you are interested to know what the European Union in their projects is doing, you can join us also on these workshops. This is free workshops and webinars. Emission monitoring in different scenarios, different sectors. Please join us. And there are a lot of conferences that we also do where we present these results. So if you would like to know more about it, please join us, and we will be happy to share you the results of what's happening in the metrology world. Thank you very much.
Thank you very much, Dr. Fernandes. Do we have any question or any comments?
There's one there. Sure.
Thank you very much, Professor Fernandes. Great presentation. My question is about where Germany is going to get the hydrogen. Is it going to come from domestic sources? Thank you. Again, great presentation, Professor Fernandes. My question is, where is Germany going to get the hydrogen, from domestic sources or from international sources, from Canada, wind energy, Norway, or solar from Morocco and Spain? I'd just like to get your thoughts on where the mix is going to come from.
Yeah, I think it will come from all sources. I mean, Germany is producing hydrogen, but not enough, and only in the summertime, most probably. But yes, we have an agreement with Canada. We have an agreement also with India, also in Namibia and Morocco. I think it will come from everywhere. The big question also is whether this hydrogen is green, because Germany only wants to import green hydrogen. And you know, many countries are producing hydrogen but not green. They are producing from carbon sources, from cracking methane or other ways. The question is, can metrology really detect the green hydrogen? This is one question which we have. The purity, of course, I talked about. And we have from the government a mandate basically to look at all these aspects, the color of hydrogen, the quality of hydrogen, because a lot will be done with international trade. So we will be importing in the future, there's no doubt about it.
Okay, one more question, please.
Thank you so much for your presentations, Professor Fernandes. I have seen your last slide with the H2 frame. That is a combustion, right?
Yes.
And so now today we have like a fuel cell hydrogens, but are you still working with the hydrogen combustion? So is there any like applications that it apply normally?
Yes. So again, the second question is a very good question, because we don't even know where this hydrogen will go in the future. Mobility is too expensive to sell hydrogen, to use it in that particular sector. I think the major priority for Germany right now will be the steel and the cement industry. Okay, so mobility will be maybe possibly the last option, but of course combustion is also intended to. We are technology open right now. Of course, fuel cell will be the leading technology for hydrogen use in the mobility sector, but requires very high grade hydrogen. Combustion, for example, you can burn anything. So in that you do not need high grade hydrogen. So if we have impure hydrogen natural gas mixtures, it could still be used in combustion. So the application of hydrogen use in combustion is not basically stopped. It will continue. So there are many people still working on combustion engines with hydrogen enhanced natural gas. Yes.
Okay, thank you very much. Let's join me to give our big hand to Professor Fernandes. So we will now take about 10 minutes. Sorry that I have to reduce the duration because since we are behind the schedule, a refreshment break, and we will reconvene again at these rooms. So please enjoy the break and see you soon ค่ะขอบคุณค่ะ It's okay. That's perfect. So we begin the session shortly. Welcome back to the symposium. I hope you enjoy the networking sessions and refreshment. We will now continue with the second technical presentation sessions. Our next presentation will be delivered online by Dr. Hong Lin. His talk is entitled China's Implementations of Energy Measurements for Efficiency and Carbon Reduction. Dr. Hong Lin is chair of Asia Pacific Metrology Program, Climate Change and Clean Air Focus Group, and a senior leader at the National Institute of Metrology of China, or we call NIMT. He is an expert in thermophysics and environmental metrology with extensive experience in developing measurements frameworks that support carbon reductions, energy efficiencies, and climate action. Under his leadership, the Focus Group has strengthened collaborations among national metrology institutes across Asia-Pacific regions to support sustainable development. Now, Dr. Lin, the floor is yours.
Okay, thanks for the introduction. I'll share my screen. So can you see my presentation?
Yes, crystal clear.
Okay. Okay, hello everyone. It's my great pleasure to give a talk about China's implementation of energy measurements for efficiency and carbon reduction. I'm from National Institute of Metrology, China, and also from Zhengzhou Institute of Metrology, China. So I will start my talk about my presentation in three parts. One is about the national strategy for carbon peak and carbon neutrality. So for now in China, the carbon reduction is the main issue combined with the energy efficiency. So most of the time, the energy efficiency problem will be emerged into carbon reduction. And in 2020, our President Xi officially announced the 30-60 goals for carbon peak emission and also carbon neutrality. And then a lot of regulations or guidelines from government were published to get to this goal. For example, from our state administration for market regulation, they published the strengthen the research and application of the key measurement and the testing technologies in carbon emissions, and also from some other divisions. And the whole idea, is China. Chinese government published the 1+N policy framework for the carbon peak and carbon neutrality. As I just said, the energy efficiency problem was emerged into this 30-60 goals. For this whole framework, 1+N, 1 means the main working guidance for carbon dioxide peaking and carbon neutrality in full and faithful implementation of the new development philosophy, including 10 aspects and 31 key tasks. So for the N, reference including the 10 action plans for different industry and fields, and also a variety of guarantee policies. For example, I listed the 10 action plans from different fields, including the green and low carbon energy transition, energy saving, carbon emission mitigation and efficiency improvement, and also the peak carbon dioxide emission in industrial sector, and so on. So this is the main 10 actions. It's very important in China, and also some guarantee plans, which give this 10 action some guarantee policies, for example, from the science and technology supports, and also from the standard of the metrology system, that's us, and also from the energy security, carbon sink capacity, and so on. And there are lots of, I list only 6 of them. And actually, for us, metrology serve a very important role in this job, especially for three parts. One is from the National Carbon Emission Inventory, and second is from the enterprise carbon emissions. This means the, for example, carbon trading market, and also the product carbon footprint, especially for the carbon tariffs. So the second part is I will talk about something about the policy support, the details about the policy, how to support the carbon monitoring, accounting, and the measurement metrology system. So the first thing I talk about is about how to support the national greenhouse gas emission inventory compilation. And the main thing is we build a very big carbon monitoring network. The government published several guidelines to help the local government to build greenhouse gas monitoring network, including CO2, methane, F6, and so on, and also including some air speed, temperature, pressure, and humidity, and wind speed, and all these things related to meteorological parameters. And also, the government have some policy for development of the carbon emission inventory, just for some rules on how to build a national inventory for cities, for states, or for even for the national level. For example, first to establish a multiple scale carbon assimilation inversion system to study assessment of the carbon source and the sink, and also improve the compilation mechanism, and also carry out dynamic real-time for coverage for the whole CO2 emission, and so on. The third part is about carbon trading market. It's quite important now in China. The power plant and cement industry were included in this market. So every year we have to do a lot of work, try to evaluate the data accuracy. For this part, so the first thing is the initial CO2 emission online monitoring, just monitoring system, just the SIMS, continual emission measurement system, especially for the thermal power plants. And then from power plant to steel cement plants, now is in cement plants phase. And the third step 3 is to refine the flow rate parameters and also the concentration parameters to get the carbon emission. And then carry out the regular analysis and monitoring of carbon emission trends. So all these things are published in the government main page. And for the carbon accounting technology, and this part is to ask for our metrologists. We established some standards. Environment guidelines and also for the
Dr. Lin, your voice is quite delayed. Let we solve the issue at the moment. Please wait a little bit. So can you try to speak, Dr. Lin? Dr. Lin, are you there?
Dr. Lin, yes. Can you hear me? Yes. I can hear you.
Okay, maybe it's okay now. So please continue. Thank you.
I'll turn off my video, so you can hear me now, right?
Yes, we can hear you.
Okay. So for the product carbon emission measurement system, that's for the carbon tariff, also some guidelines. I will not go to details, so I'll go to the next page. This part is very
excuse me, now you are showing your video, right?
I'm showing my presentation.
Your presentations, now it's just the cover page. So please.
How about now?
No, the slide's not working.
I'm sorry, just give me 1 minute.
Our technical team tried to solve the issue. So can you try to reopen your presentation again?
How about now? Can you hear me?
There is not the issue about the voice, but about the presentation. So now your presentation is not coming.
Okay. Let's share my screen. So, can you now see my screen, my presentation?
It's now the black screen on our side. So now I can see your slide. Okay, now it's okay now. Dr. Lin, please continue. Thank you. Dr. Lin, now we can see your slide, so you can continue your presentation.
You can hear me, right?
Yes, I can hear you.
I'm really sorry, I cannot be in person in China. I'm sorry. So, as I just said, I mentioned something about the Chinese policy to support national inventory and also carbon trading market, and also now it's about carbon metrology standard system. So it has a strong relation, have a very strong. It's connected with our work, because we are metrologists. So this policy required first to establish and improve the carbon metrology standard facilities, and the second to establish and revise standards for greenhouse gas monitoring methods, instruments, online monitoring system, and control platforms. And the third, and also need to improve the carbon metrology service system and at all levels. For example, to equip marine instruments and also clarify emission standards. And the fourth is to study on the key standards and the technologies of metrology for quality control of carbon data. And the fifth is to establish international recognized carbon metrology standards, carbon monitoring, and effective evaluation mechanisms. So this is the whole policy. I cannot go to very details because the time issue. And if you have a strong interest, you can look up into the main page of our central government to see what's going on. So the third thing I will mention a little bit about NIMT's work on this part. In NIMT, we have built several technologies. For example, for the point source emission in this level is for the industry. The uncertainty is now is between 1 to 2.5%. For the uncontrolled fugitive emission, it's about 10%. For the carbon flux in whole cities is about 25%. The uncertainty. So we know the emission equates to point size emission plus fugitive emission. So for the point source emission, we build the best ever wind tunnel. It's a traceability system for stack emission. It can cover to 190,000 cubic meter per hour. Combine this three-dimensional pitot and cover to this range, which can apply to all the industry flow rates in China. This is the whole system. For the fugitive emission, we use a differential LiDAR. Actually, this is from MPL. Can measure different gases. We use this to measure the methane emission in some oil refining factory. It gets us quite good flux results for emission rates. And also we measure the landfills. And also we use this to measure the CO2 emission for the some factory, which have uncertainty about 10%. We also built some traffic high-resolution emission inventory system based on measurement to help government to understand where the traffic emission come from and how to deal with this. And for the immersion model and the inventory, and we also construction of the metrology system for the ecosystem of carbon sinks, a notable paperwork. And also we built a system for carbon sink measurement. And we also did some international comparison of European methane emissions. So this is the first detailed methane inverse modeling in the comparison, specifically targeted Europe in the past 15 years. We also published a paper with all the colleagues. And now we are doing the international comparison of methane region inversion for the whole Asia Pacific region. And also for my group, we published 30 national metrology technical specifications, including 27 items related to carbon emission monitoring and 3 items related to inventory, carbon accounting, and also the footprint. And also 5 national standards for the greenhouse gas emission accountings and 2 group standards related to differential absorption LiDAR. So this is all. Thank you.
Thank you very much, Dr. Lin. So now I would like to open the floor for questions or comments to Dr. Lin.
Yeah, Dr. Lee, a great talk. I'm just wondering where the metrology challenges you see in China for the near future in this field. You know, people talk about sensor networks, sensor technologies. Digitalization is catching up. What would be the role of these new technologies coming up in your monitoring, reporting, and verification? Where is China stand at the moment?
Okay, thank you for the question. Actually, for us, actually, accuracy now is the main work we need to do. You know, for the carbon emission in stacks, the flow rate and is quite difficult because there are a lot of turbulence in the stacks. So we needed to get uncertainty below 2.5% with K equals to 2. So this is very quite a challenging issue, and the government required that we need to work to this uncertainty level, 2.5%, and for the actually we're quite close to this goal. And as I just said in summary, the accuracy, the data quality now is we pay a lot of attention to this part. Thank you.
Thank you very much. Is there any questions? So if not, please join me, give our big hand to our speaker, Dr. Lins. Thank you very much for joining us today.
Okay.
Thank you. Our next presentations will also be delivered online by Dr. Pim Supha Ghachang. Her talk is entitled Trust Measurements and Bankability, Perspective on Green Energy Financing. Dr. Pim Supha is a researcher at the Engineer Research Institute, Chulalongkorn University, specializing in energy policy, economics, and sustainable energy transitions. Her work focuses on renewable energy development, solar PV deployment, innovative financing mechanisms, and low-carbon energy pathways. Please join me in welcoming Dr. Pim Supha. Dr. Pim Supha, the floor is yours.
Thank you very much. Do you hear me clearly?
Yes, very clear.
Okay. Thank you very much for having me for today's session. So my name is Pim Supha Ghachang. I'm a researcher at Energy Research Institute, Chulalongkorn University. So today I would like to share a perspective on why trusted measurement and bankability is important for green energy financing. So for the outline, I will cover like 5 main topics. First, why trusted measurement matter for the green financing, and we'll look at the case study from Thailand about from the grid parity to financing gap, and we'll sharing findings from our study about investment risks that affect the project bankability. And then we'll touch upon about why trusted measurement will become as the de-risking tool and the key takeaway. So first of all, before I discuss about the Thailand case study, I would like to sharing a bit about why does green energy finance require trusted measurements. So if we're thinking about green finance instruments, so we we'll mainly talking about the green loan, green bond, green equity, blended finance, or the concession finance. But in order to use these financing instruments, so every investment decision need to look at how can this project generate reliable long-term cash flow. So that's why trusted measurements become important. So for your right-hand side, you can see that the type of the measurement that investor or the lender rely on throughout the project life cycle. So it includes resource assessment like solar, irradiation, temperature, reliable energy use assessment, equipment testing, certifications, performance monitoring, and also the independent verifications. So this measurement provide the technical evidence that project will be performed as expected. If you look at the flow of the bottom of the slide, so it can translate how the technical information into the financial outcome. First, trusted measurements reduce technical uncertainty and will increase reliable cash flow projections for developers and lenders. and they will have their strong confidence for the future electricity generations, and more reliable projection lead to stronger lender confidence, and which improve the project bankability, and finally can be greater access to the green finance. So now I would like to just simplify this into 4 key messages that explain why trusted measurements are important for the project financing. First, the green energy projects are different from the conventional infrastructure project because the green energy projects are financed based on the predictable future cash flow, not the current assets. And second, is there any technical uncertainty, for example, resource assessment, system performance, degradation, and equipment quality, also direct impact for the energy yield and project risks. Third is the trusted measurements can reduce uncertainty through the reliable data testing, monitoring, and independent verification. Finally, it could lower technical uncertainty and improve the cash flow predictability, and also can build the lender confidence and can enhance the project bankability. So let's take a look at the case of the Thailand. For the Thailand solar opportunity and financial gaps. So Thailand has the enormous solar potential based on the study, the technical solar potential more than 300 gigawatts, but is still using less than 2% of the land area. And however, by the end of the 2024, the number of the installed rooftop solar PV is just 3.3 gigawatt, which means that is still a very small portion of the available potential has been developed. So based on our study that I will discuss in the next few slides, so we found that since the rooftop solar already technically and economically attractive, but while the deployment is still limited, so we identify that it's because of the investment risk rather than the technology. So we identify about 57% of the total investment risk premium that are identified for 4 priority risk categories. So despite the rooftop solar PV reaching the grid parity in all sectors since 2019, but the adoption still below the potential. So based on the study, find that policy, regulatory, and financial risk barriers increase the cost of the equity and the cost of debt, that making the bankability is the main barrier for the green energy financing in Thailand. So based on our finding is from the case project is clean, affordable, and secure energy for Southeast Asia. So we did the study in 2 years ago in order to understand why the rooftop solar deployment remain far below its technical and economic potential. So in this study, we try to identify the risk in order to unlock the solar rooftop PV investment in Thailand in our scale. And for the next slide, I will show you the 4 priority risk categories that have the greatest impact on the financing cost. So this figure is the risk waterfall results. So it shows how different risks contribute to the financing cost. So the 4 main risks are the administrative and permitting risks, power market, and financing risk is the critical to lowering the cost of the rooftop PV investment in Thailand. So we on the left, so we analyze the impact on the cost of the equity For the cost of the equities mean the return that investors expect before they are willing to invest their own money. So it found that administrative and permitting risks has the largest impact, with the power market risk and developer risk together is the increase the cost of the equity by 2.4%. And for the cost of debt is the interest rate that banks charge when they lend money to the project. So for the cost of debt, the top three risks is the power market risk, developer risk, and financial risk together increase the cost of debt by 1.7 percentage points. So it means that the total debt risk premium that contribute like almost 60% of the total financing cost. So it means that most of the barrier is not driven by the technology, but is strongly influenced by the project risk. And just give you a bit detail about 4 priority risk categories that affecting the project bankability. First is the administrative permitting risk is involved with the complex multi-agency permit, no centralized platform, and inconsistent equipment registration between AVA and PEA. And the second one is the power market risk. Is that involved like frequent policy changes, uncertainty, compensation mechanism, and the unclear long-term target, which the undermine investor and lender confidence. Third is the developer risk is also lead to the due to the no developer review or rating system. There were uncertainty about the third party ownership, and also there is still no recognized certification system or quality standards. And finally, the financial risk is related to the financing environment itself, like for example, the unattractive loan conditions, maybe and the lender focus more on repayment history over the project cash flow, and also the exposure of the exchange rate from the imported PV equipment. And just touch a little bit about the LCOE calculation as well. From our study is proved that the Thailand solar rooftop PV is already achieved the grid parity across all scale residential, commercial, and industrial sectors. So the cost of the the cost of the electricity generated from solar is cheaper than the average retail electricity prices. And result we were derived from both stakeholder survey data and using the program simulations under different financing model. But solar with the battery is still not much economically attractive due to the price, but it needs the policy supporting in order to make them achieving the grid parity. And also our study provides some of the policy measure recommendation in order to improve the policy de-risking instrument for rooftop solar PV in Thailand. First, like it needs a long-term rooftop target and well-designed rooftop solar program, and also in order to reduce risks from the administrative and permitting, it needs a one-stop service, and also the permitting process needs to more streamline and also involve with the grid and transmit risk that should be reduced. It can be the open for the hosting capacity information, grid code modification, and also provide the platform and standardize the equipment and the vendor registrations. And so far we have seen that Thailand financing barriers are driven by different types of risks, and many risks originated from the uncertainty, like technical, regulatory, and market. So how we can reduce that kind of uncertainty? So trusted measurement is become the foundation of the project bankability. So for this slide, summarize why the foundation of the project bankability. First, for the process, start with the trusted measurement, which includes the verified energy use data, standardized measuring, and also certified equipment. And when those measurements then create the transparent and reliable data rather than rely on the consumption data or the developer estimation, so lender can have the access to the confidence and verifiable project information throughout the project lifetime. And as a result, it improves the lender confidence because the project cash flow become more predictable, lower risk premium, and improve the long term. And finally, this leads to more bankable green project because it's lower cost of debt and no longer loan tenors, and also can broader access to the green financing. And since we have discussed about trusted measurement that can build lender confidence, so I would like to give you 4 practical examples that if that kind of the trusted measurement are missing and still some technical uncertainty become the financial risks. First example is the load profile measurements. So most often the customer that would like to install solar, they only have the monthly electricity bills rather than the hourly consumption data. So this kind of the information can maybe lead to difficult to identify the proper size of the PV system or estimate the sales consumption accurately. As a result, when project the electricity saving can become less reliable or impact to the future cash flow. For the second example is about the solar result measurement. So if the solar radiation or the temperature data are inaccurate or insufficient, so it leads to the uncertain about the energy use forecast, and this also affects to the less reliance, especially for estimate the term of the P50 and P90 that lender commonly use to assess the project performance and repayment risk. Next is the performance monitoring. So it's about if the project lack of the continuous monitoring, so the performance losses may go a longer period, and it become more uncertain about the actual performance and the difficulty to demonstrate that the project is meeting the expectations. Not just about quality verification is also important. It needs a proper testing, inconsistent the EPC quality, and also the documentations. So and also if can make the technical due diligence more difficult before improve alone. So these are the some technical uncertainty that can become the financial risk. So last but not least, if we have seen that the technical uncertainty can become the financial risk. So how trusted measurement can be applied to reduce that risk? So we can see them throughout the entire of the project life cycle, not only like after the project start operating. So this table is illustrate how trusted measurement support bankability from the very beginning of the project until the long-term operation. First, during the pre-build stage, we focus on reducing the uncertainty before the investment made decisions, include the PV planning using the simulation software to predict the yearly electricity output. Need to rely on certain of the solar irradiation data, and also the estimation of the degradation rate throughout the project lifetime. And during the construction process, is need to see about the quality assurance. So the component should be independent review. The component should be tested and the construction should be independently reviewed and the monitoring about the construction. And also the EPC contractor should be qualified and have the technical standard. And finally, for the operations state, it's about the continuous monitoring. It's also essential. It involves like advanced monitoring system with the regular inspections and also have the proper maintenance in order to see that the project is performing as expected. And also the information is also valuable, not only the project owners and also in terms of the O&M maintenance on site should be monitoring continuously in order to monitor for the performance of the project operations. And finally is the key takeaway for today's presentation. So let me conclude 4 key messages. So first, Thailand has already achieved grid parity, but the financial barrier is still largely on the investment risk, which can continue to limit the renewable energy investment. Second, technical uncertainty can become the financial risk because it could potentially reduce the lender confidence in the project performance and also the future cash flow. So for the trusted measurements would provide the technical evidence needed in order to reduce the uncertainty throughout the project life cycle so that it could improve the lender confidence and strengthen the project bankability. And finally, green financing is not about making more capital available, but it depends on having projects that are technical, reliable, financial predictable, and therefore it makes the project can be bankable. And yes, it would be that would be all for my presentation.
Thank you very much, Dr. Phimsupha. And now we can have quick questions, 1 or 2 questions from the audience. Or any comment? So for me as a scientist, it's kind of opening my eyes about the financials, and it's my first time to hear the word bankabilities. And thank you for Dr. Phimsupha for sharing the clear idea that the relationship between bankabilities and how the measurements can be useful for also for this field. So we have 1 question from Dr. Fernandes.
Yes, thank you very much for your nice presentation on the economic aspects. You mentioned about developer undisclosed life cycle risks based on developer assumptions which are given there. How could one actually reduce these uncertainties on this particular risk? Maybe by working with metrology institutes here like in Thailand and MIT, NIMT, to see whether there could be metrology supported life cycle analysis in the future. You know, we also look at process efficiencies through accurate measurements on certain critical parameters. Is this also something which one could do in the solar side? Because you say, okay, you do not know the life cycle, lifetime of these solar panels accurately. So it's a number which is given, but how can I know really that it's reliable and whether one can rely really on NIMT and metrology institutes to provide technical expertise on this to basically nail down better accuracies? Is this something helpful?
Yes, thank you for your question. Actually, this kind of the, the term of the trusted measurement is kind of the new for me as well. But when I talk to the solar developer in Thailand, that about the trusted measurement, they're usually talking about the data simulation, like for example, for the solar irradiations or the future electricity generation based on based on the project. I'm not sure like I'm gonna answer your question, but recently like in Thailand, most of the solar developer they only use the PVC software that kind of like historical data in order to forecast for the electricity generation, and also the solar radiation is still limit as far as I know. In terms of the program itself, or in terms of the data that are available in Thailand. So it's also difficult for the solar project in Thailand as well, in order to access to all of the project life cycle that I already mentioned, because that one is a very good framework. So I'm not sure that I can provide you a good answer about the methodology, but the thing is, if we have some kind of the improved data or the real-time data or the open source that can be more in-depth for the forecast analysis or for the electricity generations throughout the project lifetime, I think it would be good for to know that what kind of the cash flow for throughout the project.
Yeah. Thank you.
Thank you very much, Dr. Pimsupa. So let's join me to give her a big hands once again. Thank you very much. Since the time constraint, we will move our final presentation from Dr. Oijai Ongrai to the afternoon sessions. So I know that everyone is looking forward for a lunch break, but we are almost there. Before that, let's capture the special occasion with group photos. So firstly, may I invite the chair of event, Mr. Dr. Jaran Yafa, and NIMT executives and all invited speakers to the stage for a photo shooting. And also the audience, please wait a little while because we will have photo together after we're taking this shot. And also the invited speaker afternoon session, please be on the stage as well. Thank you. So next, with the audience in the room, so maybe you can turn your back here, and then let's gatherings in the middle, everyone, to join the photo. Let's take a photo together. The cameraman, please wait for. เห็นไหมคะข้างหลังโอเคอีกทีนะคะ please give your big smile Okay, thank you very much. And now it's time for lunch break. The afternoon session will begin at 1:30 p.m. We wish to see you again. ขอบคุณนะคะขอบคุณค่ะ afternoon, everyone. I hope you enjoy your lunch. Thank you for staying with us and welcoming back to afternoon sessions of International Symposium on Trust Measurements for Sustainable Energy Future. We will now begin our first panel discussion entitled Trust Measurements for Hydrogen and Emerging Energy. Let me introduce our distinguished panelists. Our first panelist is Professor Dr. Ravi Fernandes, Head of Departments of Physical Chemistry at National Metrology Institutes of the Federal Republic of Germany, or PTB. Following his insightful presentation this morning, we are pleased to welcome him back to share his perspective in this panel discussion. Please welcome him together. Our next panelist is Dr. Nithida Nakprisha, a senior researcher at the Energy Research Institute with over 20 years of experience in energy and climate policy. Her expertise include energy transition, decarbonization pathways, greenhouse gas mitigations, and hydrogen technology. She has worked extensively with government agencies and international partners to support Thailand's transition to low carbon future. Please welcome her. Thank you. Our third panelist is Dr. Grisada Wanathong, a research specialist in powertrain at PTT Innovation Institute. He has over 2 decades of experience in engine and powertrain technologies, with expertise in combustion control, hybrid and electric vehicle system, and energy storage. His patent innovations and research have played an important role in advancing sustainable transportation technology in Thailand. Please welcome him together. Finally, moderating this panel discussion is Dr. Oijai Ongrai, Chair of APMP Energy Efficiency Focus Group and Senior Metrologist at the National Institute of Metrology, Thailand. As many of you will remember Dr. Ongrai, she has organized this symposium. We are delighted to have her back to moderate today's discussion. Ladies and gentlemen, please give our panelists and moderator a warm round of applause again. Dr. Ongrai, the floor is yours.
Thank you, our beautiful MC, Ms. Farah Kanawan. Good afternoon, distinguished guests and colleagues. I'm Oijai Ongrai, Chair of Asia Pacific Metrology Program APMP Energy Efficiency Focus Group. We are entering the exciting era of hydrogen, renewable fuel and battery, smart grid, and low carbon technologies, right? However, behind every technology lies in fundamental question. Can we trust the measurements? Today, we are fortunate to have an expert here to represent the metrology, standard, academia, industry, including myself, in terms of regional collaboration. Let us explore how trust measurement can accelerate the energy transition. To start, I would like to invite each panelist to briefly introduce yourself and sharing what exciting you most about the hydrogen, carbon capture, or emerging energy technology today. Maybe start with Professor Ravi first.
Thank you very much. Good afternoon here. Ravi Fernandes from the PTB, the National Metrology Institute. And it's nice to be here. Of course, what excites me most about renewable energy is, of course, as I said earlier in the talk, the future is renewable, the future will be sustainable. It is driven by many, many factors. You also have stringent laws in almost every country. You have the standards driving that. And of course, it's the right time to do that. Climate neutral, sustainable development goals from the UN. And it's the right time also for metrology to be part of this energy transformation system. Why? Because I think metrology is the pillar for trust in the system. We bring the facts, the data, reliable data, accurate data, and based on this data, this can help policymakers implement them and build trust in the system. I also said earlier, in Germany we had the nuclear power plants, now no more because of one accident which already caused for the society a big concern, and they are worried also about new technologies. So new technologies being fear, but metrology, as a National Metrology Institute, we bring in facts, we bring in data, and based on these data we can help governments do the right decisions. We have the legal metrology for the consistent implementation of this policy. We have scientific metrology which brings in innovative technologies, innovative methods. But always the question is how reliable is it? Are they traceable? Can we equip calibration systems? So to be a part of such a transformative energy system, I think it's a great honor for a metrology to be at the right time.
Okay, how about you, Dr. Nitida? What exciting you most about hydrogen era?
Right. What excites me most about this kind of technology is that their potential to decarbonize the sector that is hard to electrify, also called hard-to-abate sectors. And as the policy researcher, I have been working with many energy outlook and climate scenarios that outline the pathway to net zero emissions and to have the deep emission reductions. And in almost every scenario, hydrogen and CCS and all these emerging technologies play an important role. And for many years, all of this technology exists mainly on the models and scenarios. But today, we are seeing them move closer and closer to commercial deployment. So I think that's very exciting to me. Don't you think?
How about you, Dr. Krisada? What do you think?
So we have some discussion, and I said that what excites me more today is to be here, to sit here. This is quite exciting. Yeah, I'm research specialist. Yeah, I'm really happy when what I think, what I develop in the laboratory, in the theory, can be moved, can be transferred to the real application. This is what I always excited about that, and I think the same thing for the new technology like we already discussed about the hydrogen, about the CCUS, or any smart grid. So what excites me more is to see that move from the laboratory to the real application. This is the, yeah.
Okay, thank you very much. So let's start with round one question. Are you ready? Professor Ravi, from the perspective of the National Metrology Institute, what do you see the biggest measurement challenge for hydrogen in the coming decade?
Sure, there are a lot of challenges for hydrogen. I also said earlier, hydrogen brings in a lot of safety-related issues, which is a concern for many. Especially, you see the explosion limits are really in the threshold that you have to be careful, and especially for the society, they want to really know, is it safe to bring in hydrogen or do something else about it. So metrology has to also see that. The other thing is the quality of hydrogen, because every application has a different quality requirement. If you look at the fuel cells, you need very high quality, high pure hydrogen. But also for other applications like combustion, you don't care about what the purity is. And I think this is also a problem. Do we have gas grids with a high purity hydrogen? Or if we have hydrogen in the natural gas grid, do we take that out and then we bring in new technical challenges for a particular application like fuel cells? So Germany is already thinking of now pure hydrogen gas grids. It's a huge investment, of course, for one particular industry, which is maybe the fuel cell industry, but many others might not need this type of purity. So for metrology, it's of course important to cater the needs of different applications, from fuel cells, from transportation-related issues. One of the biggest challenges also, hydrogen is so small, it affects the material compatibility. So material science becomes again an issue. So a lot of technical challenges there, and I think we are come a long way. And one of the biggest challenges, I would say, for the globally, because energy is a global problem, hydrogen will be in the future a global problem, is the technology transfer, to do comparison, to help other nations who are not yet there, to bring them on board. So yeah, and I think this is really exciting.
Yeah, I heard that you're also working along with the international standard, right? Like ISO or IEC, that often invisible but essential. So what do you see as the biggest challenge for methodology and standard for net zero transition?
Standardization organizations, industry, and metrology institutes have to work together. Some see these as barriers, technical barriers. We see that basically we are removing the barriers to enhance trade. And as I said, hydrogen will be a carrier which will be internationally traded. So there are different rules and regulations from different countries. We need to harmonize these together. So ISO and organizations like this need to come together. We want to work with industries together. Not that someone decides, but we decide together and see where we need to work, where to bring industry on board, sometimes research on board. And so what I would say in one word is work together.
Yeah, that's a very important point. Because innovation can move quickly, but without standard scale being difficult, right? So next question to Dr. Nitidhar, maybe you're ready. So from the research and policy perspective, where are the largest knowledge gaps today?
Right, I can see two major knowledge gaps. First, we still need more evidence from the real-world application. Real-world deployments, as most of the data and assessments we currently have are based on engineering designs, models, and pilot projects. And you have to admit that when technologies are at a large scale, unexpected operational challenges often arise. So we need to understand, to have a better understanding of how this technology perform under the real operating conditions over time. And second, we need a better understanding of a broader ecosystem to support these technologies. Well, you see, either hydrogen or CCS are not standalone technologies. They need supporting ecosystem, and their success heavily depends on the entire value chain, including infrastructures, laws and regulations, and as well as the standards and the markets, the financial mechanisms. So without knowing, without understanding how these pieces will fit together, we cannot move all of this technology from pilot projects to commercial scale, right?
Thank you very much. So size and measurement and standard become the bridge between the innovation and policy making. So this question to Dr. Krista. Dr. Krista, from the industry viewpoint, what the key factors that influence investment and deployment decision for emerging energy technologies?
Thank you very much. Actually, I'm also working in the laboratory as well. And my boss always asks me about, how to, bring the thing to the market. And the most important thing that always discuss is about the cost competitiveness. Yeah. So if we have quite expensive hydrogen, example, or the system, it's not going to happen. So the cost is the number one, from my opinion. And yeah, policy. So like hydrogen again. So we need some support from government. Yeah. So we cannot work alone. Yeah. And policy certainly is quite important on that. And another thing is about the risk management, safety, because and again, as Professor Ravi said, that if it happens and then it's not gonna work anymore. So for hydrogen, we cannot make accident happen. So we got to keep it quite safely. And yeah, of course, the quite important thing is about the standard and the accurate and the credible measurement is very important on this point. Yeah,
Thank you. So industry ultimately need the confidence that measurements are reliable enough for operational and investment decision. Thank you. So we are going to the round 2 of question about the are we ready? So hydrogen is increasingly viewed as a globally traded commodity. So one question in my mind is, are we truly ready for international hydrogen and CCUS implementation? Maybe start with Professor Ravi first.
Yeah, well, it's different, I would say. If you look at Germany, a lot of developments there. In some countries in Asia, not yet. So we are partly ready, but not yet there, because there are a lot of questions to be answered on these sides. A lot of new technologies, measurement technologies to be developed as well. A lot of capacity building, because there is no trained staff in this particular field. So human capacity building, training workshops you need for these new energy carriers, definitely, like hydrogen. A lot has been done, definitely, but a lot needs to be done as well, I would say. And I talked about purity. It's also the hen and the egg problem. We say, oh, there are no hydrogen cars yet, but where is the hydrogen? So these are the questions to be answered. If there is no hydrogen infrastructure, there will definitely not be any cars. And so if there is no demand for the hydrogen, of course, so there will be no hydrogen infrastructure. And I think there is a lot of debate there, what has to come first. And metrology definitely cannot wait. If we wait, saying, okay, this will come and when it will be done, we will be ready, that doesn't happen. Because measurement technology also needs time to be established, to be there. So we have to already look in the future now. Even if CO2 might not come yet, we already have to think about CO2 now. What would be because then we are all right in time for the development. So we can't wait for new technologies. We have to be ready, and I think the time is now.
I support you because I'm from metrology side. So, Dr. Nitida, do you agree that measurement infrastructure may become a problem for hydrogen and CCUS deployment?
Well, I wouldn't call it a problem, but yes, I think it will become a big challenge for this technology, as we need to increase the deployment. Our stakeholder has to have confidence in both technology and data behind it, and that's why we need trusted measurement, to verify the hydrogen quality, and as well as to detect leakage for CCUS. And without all these measurements, we cannot gain trust. We cannot gain confidence. So we will face difficulties in scaling up this technology, right?
Thank you very much. I can see my work a little bit bigger and bigger. Okay, Dr. Krishna, in the same question, does industry share that concern about measurements?
Yes, this is quite important. So the measurement, we got to ensure that the technology works well. I mean, like a CCUS, we got to ensure that the CO2 can be captured, it can be stored underground safely. So the measurement is quite important. For hydrogen, we got to ensure that we have a good quality. You work with the hydrogen purity, and we need to keep quality for fuel cells. And also for the smart grid, we got to ensure that we have fast and smart and can be monitor, project, control, a rapid dispatch from the grid. Yeah, so we concerned about that. Yes.
Thank you. So if I may summarize, producing hydrogen is not only part of the story, right? We must also agree how to transport it safely, how to measure it, certify it, and quality compare it internationally. So, okay, we come with round 3 about the emerging energy technology. So beyond the hydrogen, we are seeing the increasing interest in ammonia, synthetic fuel, battery system, carbon capture, and smart grid. So what technology require the most urgent measurement development? So maybe who wants to start first? Maybe Professor Ravi.
I'm always the first. Thank you for being so kind. Yeah, the thing is, I think every country has its own national priority. One should always see that. So what comes first is always would be in the national interest of that particular country, I would say. Yeah, even though Germany cannot produce hydrogen, even that was a priority area of the government, because they always thought, Germany always thought, we would be the technology drivers for whatever energy carrier comes first. Okay, so, and provide this technology outside, because Germany has always been a technology provider, so doesn't matter which energy form is competitive, we have to be ready for that. So, of course, I don't have a preference for any at the moment. I would not say hydrogen should go first, ammonia can come later, batteries not, because it's also application driven. You see the future road transportation will be electric, I think, battery electric vehicles. So battery technology also is equally important, but we also have to see about the aviation and the maritime sector. They cannot put battery as a priority. They will put the sustainable synthetic fuels maybe as a priority. Right now we call that methanol might be the champagne of the future. Why people call that? Because in the maritime industry, where they want to replace diesel and make it more sustainable, so the best way is to get it from CO2 and hydrogen. So the maritime industry is working very strongly on the methanol side. For the transportation, of course, ammonia will be there. So I think we have to work on all these systems together. Be technology open and not favor any particular technology. Combustion technology will still work in the aviation side, in the maritime side, but it could be that fuel cell and battery electric vehicle will be on the road future. So we have to one way embrace this new technology, but also not forget the others. This is what I think. Thank you.
How about you, Dr. Nitidar?
Well, I quite agree with Dr. Ravi. Right. Well, it's quite difficult to identify the single technology that deserves more attention than the others. And, well, hydrogen and CCS are among the front runners, we can say that. But experience has shown us that we can be wrong in terms of estimating the speed of the technology advancement, as well as the role of the technology can play in the whole system. So why it makes sense that we should prioritize the measurement capability for those in the front runners like hydrogen and CCUS, we has to continue developing capability for the rest of the technologies, and particularly the capability that across the wider range of technologies. For example, the measurement for greenhouse gas emissions and the measurement for heat content, something like that. And all of these measurements will support certification and emission reporting, carbon accounting, which are very important for scaling up all these technologies. Yep.
Okay, let me promote a little bit about the greenhouse gas calibration. At NIMT, we have a greenhouse gas standard system. I think yesterday someone here been visit, and we are number of 68 greenhouse gas system in the world. So we have a standard prepared for this and waiting for the customer.
Perfect.
Next, please. So how about you, Dr. Grisada?
So first of all, I would like to thank Professor Ravi that talk about the combustion engine is not, gonna end yet, because I'm a combustion guy. So I still have job to do. Yeah.
Sure.
Thank you very much. Yeah. In global, Dr. Ravi already have some comment on that. I think for Thailand, probably a little bit specific. So thinking about the technology, it's not about the measurement yet. I mean, about the technology, what we already deploy. What most urgent, in my opinion, is right now we're gonna have a lot of battery, the used battery from the EV. We probably got to think about how to to rebuild, repurpose, or recycle that, and we have some discussion about the battery passport. Yeah, so we probably got to think about that, but it's not about the measurement. I do believe that the measurement in battery, like state of charge, state of health, that one is really developed and quite mature now. Back to the measurement, I think the measurement for each area is quite challenging. In CCUS, we probably have challenge about the flow measurement because the CO2 phase can really vary under the state of the storage, so they can have a kind of two-phase flow or something like that. I think this is make a lot of problem to make a flow measurement about the CO2. About hydrogen, we also have some issue like if we have the hydrogen under the high pressure, very, very high pressure. So how we measure that, how to make a flow measurement, especially on the hydrogen filling station that the pressure probably go higher than 70 bar. Yeah, something like that. This is also really important. And back to the smart grid, we quite complicated. Yeah, it's not easy, but it's look like for a smart grid or anything about this is quite mature on measurement. So my answer for this question is somehow is similar to Dr. Ravi and Rita, that it's quite difficult to say which one is more urgent. And back to the first answer is, if we don't think about the measurement, probably the battery is quite urgent for me, for my case. And it's back to the measurement. It looks like about the CCUS is more urgent from my opinion. Yeah.
Thank you very much. So we are going to the round 4 about a very important task about the collaboration. So we are gathered here for different sectors and economies. So what should be the priority for our collaboration over the maybe next year, next 5 years? Yes. What is to be the collaboration should be? So maybe Professor Ravi first.
So I think collaboration is the key for any any technology to be also drive the innovations or otherwise, you know. So I see this event here as also something bringing together government, policy, industry stakeholders, metrology institutes, academia, research. And I think everyone has to be well informed and everyone has to collaborate it right from the beginning. So collaboration is key for this. And of course, not just in a particular region, but also globally. Because energy, environment are global challenges. They are global problems where everyone has to work together. It's not a country-specific thing. So any country who has certain advanced measurement techniques, they should share their technology. They should do the transfer of knowledge, do capacity building, and collaborate. And one important thing is also interdisciplinary collaboration will be also key in the future, because a lot of these innovations need working together across disciplines, whether it's mechanical engineer, chemical engineer, physics, chemistry, because it's a holistic process what we have to look at. It's not just at one aspect. And even if you look at hydrogen, hydrogen is a bridging element in the entire energy system. And hydrogen is not alone, because hydrogen is with CO2, for example. Hydrogen is with the solar and the EV together, because hydrogen is produced from renewable energy. So you will need expertise from all these different fields working together if you really want this energy transformation to be a success story. So otherwise, this will not be successful. So I think collaboration even with standardization organizations, whatever it is, and governments have to support it. So everyone has to be involved so that the decisions are right from the beginning. Okay, so I would say it's a must.
Question for Dr. Nitida, please share your point.
Right. Well, I think the priority should be given to creating the enabling conditions for this technology to scale up. Well, you see, some of these technologies, particularly hydrogen and CCS, has already proven to be technically feasible. Well, although it can be further developed, but it's proven. So the next challenge is to integrate all this technology into the existing energy system and make the whole system work. So that requires lots of effort, lots of collaboration in terms of technology development, policy setting up, financial mechanism creation, and also stakeholder engagement. So over the next 5 years, I think our collaboration should focus on creating the broader ecosystem to ensure that we can scale up these technologies successfully. Yes.
Very much. How about you? Dr. Kisada, please.
From the industry perspective, I think collaboration is quite important. We can have some investment, but the first thing is quite important from my side. I think this about to develop the harmonized standard. So we should have the same standard. We should talk in the same story, right? And yeah, we can have some also the advanced measurement development as well. And for the industry side, we can have some investment on the pilot project, and we can share some data. I mean, we already have pilot project, and we can put some measurement and then validate it quickly. You know, this is what we can do. Yeah.
Thank you very much. For my side, as a chair of APMP EEFG, I often say that, often see that the energy challenge we face internationally, every country are faced remarkably similar. Yeah, but we are in different stage of development, and collaboration will allow us to share the expertise, avoid duplication work, and accelerate the future impact. So, I think we still have time for the floor question. Anyone have a question in this topic about the hydrogen energy? No? Waiting for solar energy already? We see exciting lady around here. Yes, I think hydrogen is very new for us, and we will learn a lot from now, and we know the expert is here. So for the final lightning round, this is, I would like to challenge you a little bit to keep only one sentence per answer. So whether for hydrogen, carbon capture, and renewable fuel or smart grid, what is the single most important action that needed today to build trust in energy systems?
I can just answer it with one word: collaboration.
Great.
Right. But I'll keep it in one sentence. Right. To build trust, we need strong evidence to demonstrate that this technology can deliver benefits they promise.
Oh, quite difficult.
You can have 2 sentences. I can give you more.
The thing that the technology cannot deploy because the public not trust us sometimes. So the trust is quite the thing to do. And how to make a trust? I think the thing is about the transparency. So if public know very well what the benefits, what the risks. So if they have trust, and then we can do. Without trust, without transparency, even you have good technology, but it's not going to happen.
All right. Yes, that's great. Because in the morning I try to give a presentation, but have no time yet. But at the end, I will give to talk something about the trust again. So for me, the single most important is strengthening regional collaboration, because it maybe not happened in Thailand, but it's already successful in Korea or Japan before about this technology. So we need to building the share traceable measurements standards, and our economies can trust the data. So we can align the policy in Asia and accelerate the sustainable energy system together. This is what I think. So I think this is maybe nearly the time is up. Thank you very much for our distinguished panelists. And today's discussion has highlighted that measurement is far more than only a technical activity. It underpins the innovation, it enables regulation, it supports the investment, and ultimately it builds trust. Whether we are discussing about hydrogen, renewable gas, smart grid, or batteries, or future energy system, trust measurement remain the foundation upon which successful energy transitions are built. So thank you for our panelists to joining us, and please give the round of applause.
Thank you very much.
ขอบคุณค่ะ ขอบคุณนะคะ ขอบคุณค่ะ Okay, back to you, Fa. Thank you. ขอบคุณค่ะ
Thank you very much.
เก้าอี้ด้านหน้าเพิ่ม1 ตัวนะคะ
So we have heard different perspectives and many ideas from different sectors. So we are gathering together, and it's good opportunities to ask more questions. And please don't be shy; we won't bite. So we will now continue with our second panel discussion entitled "Trust Measurements for Sustainable Solar Energy." Joining us for this session are 4 distinguished speakers. Our first panelist is Ms. Chidarat Sawai, an officer at the Division of Solar Energy Development, Department of Alternative Energy Development and Efficiency. Her works focus on advancing solar energy through rooftop solar and community-based renewable energy projects. She's also played an active role in Asian energy corporations, contributing to Thailand's transition to a sustainable energy future. So everyone, please welcome her to the stage. Thank you. Our next panelist is Dr. Amarat Limani, team leader of Solar Photovoltaic Research Team at National Energy Technology Center. She is internationally recognized for her research on photovoltaic performance, reliabilities, and sustainabilities. And her work has made significant contributions to advancing solar energy technology and standard in Thailand and across the regions. So please welcome Dr. Amonrat Limani to the stage. Our next panelist is Dr. Yawani Sangpong-Sanon, Research and Development Manager at CES Solar Cell Testing Center. She is specialized in solar PV reliabilities, performance testing, and measurement testabilities. Through her research on PV module performance and advanced testing techniques, she has made significant contribution to strengthening Thailand's solar testing infrastructures and supporting sustainable solar energy development. So let's join me, welcome her to the stage. Our final panelist is Dr. Thitiphorn Sangphet, Assistant Director of Business Development Division at Electricity Generating Authority of Thailand, or EGAT. With over 30 years of experience in the power sector, she has extensive expertise in power system, renewable energy integration, and energy innovation. She currently leads initiative in renewable energy, digital utility, LNG, and hydrogens, supporting Thailand's transition toward a low carbon and sustainable energy future. Please welcome her to the stage. And Dr. Oijai Ongrai will continue to moderate this panel discussion. So please proceed. Thank you.
Okay, good afternoon again. So, ladies and gentlemen, welcome to our second panelist discussion on trust measurement for our sustainable solar energy future. We have Thailand, we have a very expert in here, and fortunately we are friends as well. So maybe, this one is maybe fun, have fun with this session. So as Thailand accelerates its transition towards clean energy, solar power is becoming one of the key pillars supporting our national energy strategy. So however, beyond installing more solar panels, an important question remains: how do we ensure that the performance, reliability, investment value, and environment sustainability of solar energy can truly be trusted? So the answer will begin with measurement, I think. So trust measurement provide the confidence in solar resource, assessment, technology performance, energy forecasting, investment decision, policy implementation, and even end-of-life recycling. Today, we are fortunate to have a representative from policy, research, testing, and utility sector to share their perspective on how measurement can strengthen Thailand's solar ecosystem. So before we start, I would like to invite each panelist briefly introduce yourself and your organizations and your role to supporting sustainable solar energy in Thailand. Maybe please start with Thidarat first.
Thank you for a very cool introduction. My name is Thidarat Swai. I'm scientist professional level at Division of Solar Energy Development at the Department of Alternative Energy Development and Efficiency. Our role, as from the name, in Solar Energy Development Division, we're working on promoting the use of solar energy, not just only in terms of electricity, but also for heating and cooling. So what we're working on, not just only in urban area, we also focus on off-grid area. So pretty much everywhere across the country, we visit to help them to be able to get access to solar energy. That's the main role of our office so far.
That's why I hardly to find you because you visit somewhere else a lot. Okay. Okay, next please, Dr. Amonrat.
Okay, good afternoon everyone. I'm Amonrat Dimani, Solar Photovoltaic Team Leader from National Energy Technology Center or NTEC under NASDAQ Thailand. And at NTEC, our research range from the fundamental applied research to testing and in offline management of the solar PV. And NTEC focus on the PV technology validations and also the performance and reliability assessments under the real world operations. And also we'd like to find the solutions for the entire solar PV life cycle in Thailand. And I think I'm glad to be here today to discuss how trust measurements and reliable data can support PV adoption in Thailand. Thank you.
Dr. Yawani, please.
Thank you. Thank you. Good afternoon, everyone. And thank you, NIMT, to invite me to join in this session. Thank you for all of you to come to see us, to gossip like a girl gossip about PV. Yes, my name is Yawani Sangpongsanon. I'm come from CES Solar Cell Testing Center. That is my name is that you know our capability is for testing PV and equipment in PV system. Our laboratory is in King Mongkut University, and we welcome to all of you to visit us at Bang Khun Thien. That's okay. Thank you.
Great food. I like Bang Khun Thien.
Wow. Yes, great seafood.
Great seafood. Yes, please. Dr. Titpon, can you introduce yourself?
Yeah, I try to make it short, but it's going to be not that short.
Don't
yeah,
worry.
So
we
first of all,
last session, so we can go long.
Yeah, so first of all, thank you for having me here. Yeah, EGAT, I think as you may know, we are power utilities. You may think like, what are you doing here? You are talking about recycling kind of stuff. You're talking about the ecosystem kind of thing. Yeah, I just like to give you the overview about what it is all about. Can you just, put the pictures on the screen, please? So to make this clear, why we are going to jump on these panels first.
No, we keep it for second round.
No.
This is introduction.
We have there.
This is introduction.
The introduction. So, okay, the
yes.
Introductions, I would say that, yeah, EGAT, we do generation.
Yes.
We do transmission. We are the one who responsible for the power system security. Doing so, you need to make sure that you need to have power electricity to meet up with the demand all the time. Reliability, measurements of all the equipment is the key. So, however, it's not yet. So, when we're talking about generation, and right in
thinking
here,
of you when we generation.
Thinking of us. Because of generation in Thailand, we have several generations. One of the generation that in our portfolio is the solar. Yeah. When talking about solar, nowadays, we growing up, a lot faster than as ever. Yeah, for like right now, we have only about 4,000 megawatt, for example, on grid. But in 15 years from now, you're going to have, I would say that I would say that 10 times from now because of the ambitions of our country to meet up with the net zero. So when you're talking about 10 times, it's going to be about 20 gigawatt or 24 gigawatts, something I cannot remember on the top of my head. But talking about the number, it is something. But talking about the solar waste, it is the other thing. And that's why I'm here. And I like to just, call you and attention what we are going to do with our world, with our countries, and with our own house. Yeah.
All right. Very exciting already. Okay, thank you very much. So let's begin with our first round of discussion. So I would like to explore how trust measurement create a confidence across the entire solar value chain, from policy making to deployment and sustainability. Let's start with Kun Thidarat. Thailand has ambitious renewable energy target under PDP and other national strategy. From your policy perspective, how does trust measurement support national energy planning and ensure solar energy contribute effectively to Thailand Power Development Plan?
Thank you for the questions. So if I can remind back on my work, what we really have to do to use the measurement to ensure that we're going to achieve our goal. They can see into separate area. First one is the resources itself. Before you going to install your system, you have to see in advance or you have to estimate what could be the size of your system, right? And that should base on the solar energy resources. So the information that we have right now as part of DEDE, we taking care of 48 measurement stations, solar irradiance across the country, and we maintain that system very, very well. We calibrate regularly, depending on the budget that we have allocated. So we have that information that everyone can come to us and use that as the base information. But so far, we have only 48 stations, and we don't have everywhere across the country. So that could be one thing that could be one part that can support the trust measurement, that a part of the solar irradiance information, right? Another one is when we talk about the plan itself, when we compare back to the aim or the target of the plan, we're looking at the carbon reduction based on our technology. But so far, sorry to say that, but the way that we convert to that data is from statistic data, not from the real measurement. The reason I will explain why. Because the only reason that we can measure about the electricity generation is just only from people who have PPA, who sell electricity to the grid. But think about IPS, we don't have that information. Think about off-grid system that PDEDE work a lot on that. We don't have any measurement on that part. That's why I see it in two separate area that measurement can help us to really verify whether the target that we're setting up is not only the ambitious installation capacity, the number that we get, but really the real electricity generation or the real carbon reduction that we can achieve. Yeah, that is 2 points that I would like to mention.
Thank you very much. I can see that policy decisions are only strong as the data supporting them. And this is bring us to the research community. Question to the NTech, Dr. Amonrat. NTech plays an important role in developing solar technologies and supporting innovation. How do reliable measurements help to transform solar research into the technology that the industry and investors can trust?
I think at every stage of the PV research and development, from fundamental application and end-of-life management, measurements is required in every stage. And of course, we need reliable data to make sure of our experiments to validate the results. That's very important. For example, when we fabricate some solar cells and would like to measure the efficiency to test this one, of course, we need to use the solar simulator. And solar simulator need a standardized resource, reference cells, and many things that should be standardized. And if we would like to test the module outside by the sunlight, of course, we use the outdoor IV tester. That's one also we need the pyranometer to measure, and also need the temperature sensor to measure the module temperature for the calculations of our normalized power output of the PV modules. So trust measurements are really important for every stage of the PV R&D. And I think one more, when we would like to measure something, of course, standardized equipment too important. And we also need to know the protocol, measurements protocol. And of course, we need skilled workforce who can carry out the measurements correctly. So not only the equipment, but also protocol and the workforce. And I think one more important thing is how we can interpret or translate the measure result into tangible and actionable information. Because when we measure the PV module, of course, we would like to know the power output of them, but more than that, we would like to know what's wrong with the module and what should we do in these situations. I think this is really important for the investor. And I think the same thing applies to the policymaker. Based on the trust measurements, data analytics, and such a clear data interpretations, we can provide just some really benefit insights for them. Yeah, that's why.
Thank you very much. In research side, that creates innovation, but industry requires confidence before technology can be deployed at the scale, right? So question to CSSC, Dr. Yawani. People wait for you, I think.
Really? I subscribe with that.
As Thailand Solar Cells Testing Center, your work directly support quality assurance and product validation, right? So how do your testing, measurement, and validation process ensure product quality, help to reduce risk, and build the confidence in solar products and projects?
Don't waiting for me, right? Okay. First of all, I would like to introduce you to learning about the CSSC. Yes, CSSC have a testing for the PV module in Thailand, and sometimes we test for the module from ASEAN. That is come from the supplier PV module who is want to import from foreigner to Thailand and for sometime for PV power plant, and sometimes for the O&M, operating and maintenance system, to check the long-term evaluation. That means CSSC have two main duty to test. Firstly, for performance test. Performance that Dr. Amarrat said, everyone wants to know what is the nameplate. The power is exactly for the nameplate of PV module or not. Who testing for you? Yes, you come. CSSC can testing for you. And the second is for the long-term monitoring. PV module is not accepted for the first nameplate. They're talking about the degradation every year. For example, 0.5% per year. For example, and who knows if you want to test every year? Yes, you can test. CSSC can test, but not only CSSC. You can test everywhere that you trust for them. How to trust for them? Depend on the measurement. That is the really important thing to accept for the measurement is testability. That can testable to ISO AC 17025 or NIMT. That is the first law.
I'm sitting here, NIMT Thailand.
Yeah.
Waiting for customer.
Yeah. Don't believe in first of your result. Please check of the traceable tool of the equipment, the measurement that can traceable to. Did you believe it or not? Okay. See you in round 2.
Okay. So thank you. So far we have discussed policy, research, and product quality. Ultimately, solar power must operate reliably with power stem and throughout this life cycle. Question to EGAT, Dr. Titiporn. EGAT is not only integrated solar energy into Thailand grids, but also exploring broader sustainability issues, including solar panel recycling, right? So how can trust measurement support a reliable recycling pathway and circular economy approach? This is, you need slide?
Yes, now, because of, you know what,
yes.
You need to show up my slide. My team, they're sitting there. If there are no slide, they're going to be so upset. Yeah, with me. So please show on the slide. I think this is going to give you some more ideas about what we are talking about. I'm just going to focus only on solar. I'm talking about only the solar outlook. Like I mentioned previously, solar as our record, December last year, on grid only, we have over 3.5 gigawatt, 3,000 gigawatt. So with that, you can see that there are more. I would say that 1/3 are off grid that you cannot see. It's going to be on the IPS, like Kun Chidarat just mentioned. It's going to be on the rooftop of the household, on the business, commercial. So with that, meaning that in total it's over 7,000 megawatt already plugged in operation. Either it's going to be floating solar, it's going to be solar farm, it's going to be on the rooftop, wherever it is. Now, we think about not only the number of the megawatt that's going to put on massive generation. What about after their lifetime? Have we ever think about what we're going to do with that? It's going to be the massive volumes of the solar waste. Have we got any ideas about the proper system to deal with that? I think it is the time. That's why we all are here and thinking about what we are going to do. I'm just talking only about 2025. I'm not talking about the year plan on 2037 yet. When we plan, and this one is the current versions of the draft PDP 2024. We aim that the target is going to be 20. I think this slide is the outdated one. There's the other slide, but it is okay. I can deal with that. Yeah. It's going to be in total over 27 gigawatt. A lot. It's going to be 1 million something panel that's going to decommission from the farm, from your own rooftop, thing like that. So it is the time. Next, please. So I need to change the slide though, because we like to show you that we have done some work. Can anyone give me the slide with the PV label number 5? Yeah, because I think it is one thing, at least we're not going to wait until the end of the games to have the solar decommission or of the operation. We're thinking about along the way there. So right in here, should we wait? Should we have time? Yeah. I mean, I just want to draw attention from all to see the circular economies of the solar panel value chain. With about the solar panel value chain, we start from the beginning, upstream to downstream, and if possible, we like to do circular, going back. So it's like the ecosystem that can go like circular. So now we circulate our picture first, and then you can see that what the difference between ours and the pictures. Let's use the AI. Yeah.
Does it look the same? You can compare
look
first.
pretty the same. Yeah, the real is look better. But anyway.
Yeah. Can we just plug in and show her slide? Yeah, it's a slide.
Yeah. The slide is like from what I'm trying to say is trusted measurement is the backbone for the whole ecosystem. It is starting from the beginning. When you manufacture your panel, you need to have the trusted measurement to ensure that your product is in quality. QC passed as your design test run. So it's one of the measurements you need to do. Later on, when you are going to put before into the operation. Sometimes solar PV, there are two sources. For example, just I'm talking only about in Thailand. In Thailand, we have the local manufacturers. We have the importer. We import from some countries. Both, we need to measure before we're going to implement it and install into the system.
Yeah,
I think we have no time to just do the
Don't worry, because we have many rounds, so the slide can come the next round.
Okay.
So
I'm so sorry, but they're working hard. But so I'm going to stop just now, and then I'm talking about after solar number 5.
I will wait for your
later.
slide first. Yes. So the technical we will be prepared for the last slide. So. Let's go to the round 2. We have heard about the important role of each organization already. And now I would like to focus on collaboration. Very easy way because we are already collaborated somehow. So because no single organization can build the trust in solar ecosystem alone, right? So I would like to ask each panelist to answer briefly about what support do you need most from another organization to help move Thailand's solar sector forward. Maybe start with Nong Ta first. Yeah.
So I'll back to the two sectors that I have been explained earlier. So for solar irradiance and resources, we can thinking in just only solar radiation, right? But if you want to have information about the performance, the other information that you need is about the weather and climate, such as temperature, PM 2.5, or the cloud movements, for example. For that part, fortunately, in Thailand, we have several organizations who have that information already. Can be GISTA, can be Meteorological Department, I think, yeah, TBD. And we can also have, if we can collaborate with industrial, for example, every single solar power plant, they have their own solar radiation and also their weather forecast. Weather station. So if we can collaborate on that information, that can help us as a Thailand, as a country as a whole, to have the whole picture of, I say, natural energy resources that everyone can come and pick up information that they would like to have, and then they can use later on for their energy management, energy forecasting, or something like that. That could be an ultimate idea regarding the solar energy resources, natural energy resources. And for performance evaluation, one thing that we never really do it, because most of us concerned about confidentiality. We don't want to communicate what our plant produce compared to others. But if we can establish some protocol or some tools or some way that we can communicate in the way that not have any impact for their confidentiality, that can help us to have a benchmark to compare across the regions, across technologies, or across the combination of the equipment, for example. I think that could be two ideas about collaborations.
Thank you very much. Let me hear from NTech, please.
Okay, there are many stakeholders in the solar PV value chains. Of course, research institute cannot operate in a silo. We need support, and of course, we need support from policymaker, testing center, utility, metrology bodies, and also the private sector. So I think we play different roles, but I think we can function like a puzzle pieces fitting together to form a complete picture, beautiful picture, a big picture of Thailand. This is quite ideal because you know that it is quite hard to work across ministries in Thailand, and something is quite difficult thing. But that, I think that's one that we should do. But if you ask me whose support I need most and what for, my answer is I need support from the government side. Ministry of Energy, Ministry of Industry, Ministry of National Resource and Environment for. Yeah, because
any specific person
for the policy direction related to the PV waste management, because this one is quite critical for driving the PV adoptions of Thailand in the long term. And I'm looking forward to the DEDE section tomorrow because, yeah, Ministry of Energy is going to have to talk about the PV waste tomorrow morning.
It's exactly, that's what I would like to say. If you really want to know that, please come to our section tomorrow morning. We will have one section that's going to talk about how we're going to manage the PV waste.
Okay, before the CSSC, may I recheck that the slide of Dr. Titiporn ready? So we have a new version now, right? Okay. Please, we come back to the same question. So what support CSSC need most from another organization? Please.
Yes, because our colleagues told them for a lot of government that if I have collaborate with both of them, yes, I have the government, the big government come to with your partner. Yes. For me, like Dr. Amonrat, I think a lot of stakeholders in Thailand who drive the PV sector, that for PV industrial is go together and stronger. I cannot answer for one or two organizer, but that I need is, can I borrow your word, is collaboration. I need that, and the previous section told about that, transparency. I love these two of these words. Yes, if I have the collaboration with the transparency and go together, PV sector, PV industrial in Thailand will grow up like the purpose that IGAT told. But the last thing that, because in this moment, I come here to like a testing man. That needed is come from that I need for this time is come from NIMT Thailand for the testable to like a worldwide. That for ISO IEC 17025 or testable to PTB for the reference cell. And now NIMT help us to bring me to the WPVS. That's thank you. That is thank you.
Yeah, welcome. You're welcome. Okay, slide ready? Please. I would like to see.
Yeah. Next round.
Next slide.
Yeah. So maybe we go. Yeah.
To the next
We
one.
go to the next
To check
slide.
if it's
yeah.
the right one.
Yeah. I think it's the right one. Yeah. Because of the total, it's about 27 something gigawatt. Yeah. At the end of the year, 2037. Yeah. Just remind you that we're going to have consumed a lot of solar here. So go to the next slide. It's about the value chain. I'm gonna just pop in. Next slide, please. Have you? Okay. Yeah.
This is the right one? This is the right one?
Yes, the right one. When there's the label number 5. Yeah. It is the highlight though, because of when we're talking about you adopt solar energy into the system, either for the power system or your own household rooftop, you need measurement. Measurement from the starting point, from the manufacturer, like I mentioned, or even from the user. The user could be utility when you put your solar farm there, or maybe from the commercial or residential when you put your solar rooftop up there. How? And at the end, you're going to have the measurement again before your decommissioning, whether or not. That's one is question. However, the pink one is the additional feature. When talking about the measurement, the trusted measurement, I mentioned before that we need to measure the qualities of the product at the beginning, after you build up your solar panel, before you leave it from your factories. So later, you're gonna go to the distributor and then put on your solar farm. Before then, efficiencies, performance of the PV itself is the key. We never think about that because of perhaps it is the time we should appreciate how energy efficiency can help us. Me, myself, we from power utilities, but we do not need to sell that much power. We like people to realize that energy cost, it's not come for free. Everyone share. So the same, not about the cost and the price you have to pay. It is about from now on, it's the solar waste you need to bear. It is about the sustainable solar energy as a whole. So that's why we come up and initiate solar PV label number 5. We partner with CCS, the expert lab, to test the performance, to test the temperature coefficients of the solar panel itself, to make sure that the solar that's going to enter in Thailand, either from the local manufacturers or import from anywhere in the world, have highly efficiency and reliability. That's the key. Then when you put onto operation in the farm, power plant, or on the rooftop, it is the time of their lifetime, 20 to 25 years, and then it is going to be decommissioned. When decommissioned, particularly when I put like the scope of the interest, because of it is the gray area, but not many people think about. People, when they come to decommissioning, they put to the disposal, to the landfill. I don't think we have enough land if there are like a million of the solar panel. So that's why we see the whole value chain of this and make this more productivity. How? With that, maybe the trusted measurement Avenger ladies here can help us. They need to think about what are the key items we need to do and see to measure. Either when we measure, it is still in condition. So now, at what condition it is should be okay to reuse, bring back. At what condition we say that this is non-functional. No, don't do anymore. Go for recycling. It is the work, in the homework. We are going to leave it to these four ladies to help us, as the utilities. And then recycling. Right now, EGAT, we are not going to waste until wait for the result. We go along, do parallelly. We have the recycling power project, solar PV project. We run it with our strategic partner, one of the waste processor company, to see that if recycling, instead of you going to put it to the landfill, because of there's one key word that people may know, zero landfill. It is the sustainability way as well. How? Maybe not gonna go that far to the zero landfill. Maybe just only last weight to the landfill. How? So with that, measurement help. Whether or not should go for this, so measurement going to say whether or not the measurement, it's going to be less values of the material after recycling process. So this no value, if it's less value, go to the disposal again. Or if you see that there's some value, high value, should we go for the alternative materials? For example, so far we have run the system. We see that most of the material we got, it is the glass. And it is not that virgin. So the glass cost, price is so little. However, if we scale up, how much we can see. So now we are running the project and we welcome the support from people in this room. Whether or not if you have the solar panel that you are going to put off the system or decommission, please go to us. We are working on the project and we have the power plant right in Chonburi. So that's going to benefit not only EGAT because of like I mentioned at the beginning, we don't dare to do the business on this, but we try to contribute ourselves to do at most to make sure that the country cope up with the sustainable solar energy as a whole. I think that's all for me. Yeah.
Are there anyone would like to adding up in this point? Anyone? Maybe Dr. Amonrat, you do. Maybe you know about the recycling gas and.
Actually, if we start to talk about the end of life, we need one more day because we don't have a long story about this. Yeah, because it's there in Thailand we have two types of the solar PV in the solar farm. Yeah. This one and also the household type is different one and regulations for control these modules are also different. Yeah, and now NTEC also one of the organization that try to just form some format or regulations about this one. We have a platform SolarSure. We make it sure because we would like to make sure before reproposing or reuse the modules.
Very good. Okay, we are come to the final round before let fan club ask you some question. So in the final round, as we nearly conclude our discussion, what is one key action in Thailand should take to strengthening trust measurement for sustainable solar energy? Maybe start with Kun Thidarat first.
Maybe
key action. Yeah.
I'm not sure whether it will be key action or just keyword. Because the key action about the trust measurement, I think we never really established the common understanding for everyone across the supply chain. Maybe that might be one thing that we might start by having the same terminology, same understanding, so we can set up the same aim to go for this direction. I think maybe that's the first action to do, establish the same understanding on the trust measurement that we would like to have across the solar energy supply chain.
Okay, thank you very much. Maybe Dr. Yawani can adding up a little bit about one key action that Thailand should take into strengthening trust measurement for sustainable solar energy.
I'm not a bigger girl shading Dr. Amonrat,ใช่ไหม? No. That's okay. Because of I'm a testing girl. Again, the key action that I think is really important about the testing is testability. Everybody, please forgive me, I want to promote. I want to promote NIMT for the traceable to the world SI standard, like a reference cell, pyranometer, like the light source, like all of them is can traceable to the like SI unit by the cryogenic radiometer. That yesterday I visit NIMT. That for a long time ago, maybe 20 years ago, I visit NIST. That is the NIMT of
in America,
US.
Yeah, USA.
Right.
Yeah.
Right.
This is a wow factor for you yesterday.
Yeah,
right?
that is mean for today. If I pass away, okay, I can because I love that. I waiting for a long time. That is Thailand have a primary of the cryogenic radiometer by ourselves. I want to show you if we don't have the primary of cryogenic radiometer, I pay for every year like 200,000 baht every year for order the reference cell. That Do you know how long is CDC that we have a testing for 20 years? Yes, you can calculate for the money is come to another country, but NIMT support us. And for the pylanometer, that is the nearest that I can send it to calibrate is Australia. That is for DEDE and NTech and EGAT, because you not only for you have the good monitoring data and the pylanometer. If NIMT or Silapakon not calibrate the pylanometer for the Thai people, you should submit it to Australia. The cost is 80,000 baht, but it's not include the shipping payment. That is the cost. Thank you, NIMT again.
Thank you. You make me like a going very proud of my colleagues, and thank you so much. How about you?
Yeah, I try to make it short and clear. However, only one word might not be enough. I'm so sorry. Because of only one action cannot complete as a whole to myself. I would say that it's the magic of three. First, you need to build the public awareness. It is the time. You're not going to wait until the end, 10 or 15 years, and you see the problems. You cannot do much. You do it now. Do it today at your own pace that you can do. Second, you develop the circular economy pathway. Like the pathway, I just say, everyone have their own roles. You do at your best, at your own roles. Trusted measurement team, power utility, the research and innovation expert, and yourself from the metrology bodies. So we do at our best. So that's one thing. The pathway need to be clear. Who going to be the orchestra for this? Maybe should have one. Should be DEDE, should be anyone, but should have one. To make sure that there's no blocker along the way there. People get some clear message to get there. Last one, yes, close collaboration is the key. We all agree the same. Yeah, so without collaboration, you see no magic outcome. Yeah, that's the end. Thank you.
Thank you very much. Thank you very much. That's very good. And I think maybe Dr. Amarrat would like to add up something about the one action.
Key action
so
for
please.
me. Prepare equipment, protocol, workforce to keep pace with the PV new technology and diverse usage pattern like a BIPV, Agri-PV, floating PV. Yeah, this one. And also Thailand needs to enhance the PV performance testing, data analytics in the whole PV life cycle, not only for the modules, but for the whole PV life cycle. Yeah.
Any action for Dr. Titiporn from Dr. Amarrat? One dinner or one dinner or something? Okay, all right. Thank you. And now I would like to open the floor for question. If you have any question or idea, please feel free to raise them. Any? Everything clear? Okay.
Thank you very much. So you spoke a lot about the PV and solar energy generation, but what about storage? Because in Germany, I also have a solar on my rooftop, but I store most of my energy because I don't want to sell it to the government because I get very less money. So in that side, I try to store in the battery and use it for the whole day, and the next day I again generate, I store. Is this also something in Thailand, or is it just you generate electricity, and if not, you just waste that electricity, or is it going to the grid? How is this thought of in the future?
I need an hour for to answer those questions. Okay, for solar energy, from the perspective of the government, when we make any policy about that, we first encourage the usage of electricity right at the moment that they generate. So that's why the whole policy is related to anything that will encourage less the excess electricity back to the grid. As you can see, why we set the price for 2.2 is quite low, if you can see that. That's because we encourage people to use it first and sell only what left to the grid. Yeah, that's the policy until now. But at the moment, the price of battery is come down very fast. So that might be another option that can be for the future. As you can also see that EGAT might see that the dark curve, the dark curve that start to see very, very sharply in Thai electricity system. So battery can be one option that we can take it as an some tools to help us to reduce the impact of dark curve to electricity system. So that will be next phase. Then, but to answer your question, as of now, we encourage people to produce it and use it right away. Yeah.
Would you like to see the utility views about the batteries?
No, so I'm coming to that question exactly because you are so much worried about recycling, and in Germany we are not worried at all because everyone is using a refrigerator, everyone has electronic equipment, everyone has electric equipment, so it goes the same way in the directive of waste of electrical and electronic equipment. So whatever you recycle in your house, you have all electricity. So just the same way, the solar panels would be also recycled. So I never saw that this is a problem. I thought because you have glass in there, you have copper in there, maybe you have some metals in there, and everything can be recycled just the way you have your TVs, you have your refrigerators, and they also have a selected lifetime. So for me, it's like, where is the problem?
Now it's really difficult question to ask about the
problems.
problems.
Maybe we can talk in the coffee break.
I mean, but I
you
like
can
to
add up a little bit.
compliment.
Yes.
Maybe I might not be able to cover all of your questions, but what I can tell you is, in power utility perspective, we planning for generation after we have the national power PDP, so REDP as well from DEDE. We deploy those into action. We implement the generation. We have solars, of course, very much, a lot. So with solar, she mentioned dark curve. Dark curve just happened, I would say that 5 years ago, not that long in Thailand, because of the contributions and the use of the solar itself, not that much, just lately. So because of the solar rooftops, of course. So when mentioned about the batteries, solar, if you see the dark curve, one thing I want to tell you that dark curve means that it's the load curve, the use of the electricity of the people in the country. Doesn't mean that the demands of the country low. It is that they have their self-owned generation. So they consume the power from the system less. They're gonna ask the electricity from EGAT less. However, at night time, solar cannot run. So it is the time the system need to prepare itself to be ready for the user to consume the power. So either for EGAT, either have a lot of RE solar or we have our own. The paradigms of the planning nearly the same because of you say that before the peak like this, but now like this again even more. So how you going to build up generation at night time? One thing we say that we're gonna end up bankrupt for the countries if you're going to build up generation to serve just only 1 or 2 hours, either the peak day daytime before or peak day nighttime. Paradigm shifted. How? We say that maybe it is the time for the user to help the system. Good. One thing, you have your own solar. That's good. Rooftop. Yeah. So we don't need to develop or build up the new power plant. Yeah, not much. Defer the development of the power plant. In the meantime, how? You may say, how? I lost. How so? So with that, maybe we shifting the times of the use. Sometimes only you chip just the times of the use, so only the battery might not be enough. The mechanism that can use more is to incentivize the user to know the values of the use of the electricity, and of course help us to build up their own self-sufficiency. Yeah, batteries coming. At the same time, the new version, I see my team, he's already gone. He's the one who worked for the vehicle to grid. Because of when talking about the batteries, the key is the EV, though. People may surprise because of, the duck curve is not only the solar. It is about the electricity consumption, consume a lot of power because of peaking time at night time because of all of the EV owner plug in their EV at 6 o'clock to 6 p.m. to 10 p.m. for example. So would they just shift that time of consuming the power to the other time? That's gonna help the system a lot. So that's the scenario for the planning to manage the generation, either solar and battery, and we work over the recycling as well. Recycling, we come along both solar and battery, but it's because of the battery just come along later. We open up for the solar for more than 20 years. Solar farm first and now a lot in terms of the solar rooftop. And coming along more in the mass, I'm talking about the mass volumes of the battery later when we appreciate more EV into the system. Yeah.
All right, thank you very much. And anyone would like to adding up again? No? Okay. Thank you for all our distinguished panelists. Today's discussion has shown that the trust measurement is far more than technical requirement. It enables better policy, accelerate the innovation, strengthening market confidence, and support the reliable grid integration and build a sustainable circular economy for solar technologies. So, on behalf of APMP Energy Efficiency Focus Group and Organizing Committee, I sincerely thank for all panelists here and participants for joining us. I think we still have one more talk of myself, if you're still waiting, because in the morning we have no time, so I will talk when my friend is around here. And we're looking forward to continue collaboration and building a sustainable and for solar energy future and Thailand and also Asia Pacific region. So thank you very much and give more round of applause to our panelists here. Break ก่อนหรือว่าพูดเลยค่ะ We are going to for coffee break
just
and
about
refreshment and
30 minutes or
maybe 15 minutes and come back
and then we'll be back to hear Dr. Oijai presentations and summary and closing meetings. So expect to see you here. Thank you.
dialogue should be good morning, but now it's good afternoon already. So I think I can start now, right? So we can have activity or I think the traffic will be started jamming a little bit. So shall we start now, Far?
Yes, we are really happy that you enjoying talking together and have some fruitful discussion. But it's time for our final sessions that we will continue from Dr. Oijai Ongrai talk on topic why technical measurement excellence is the key to PV and green energy projects. So Dr. Oijai Ongrai, the floor is yours.
Thank you very much for the nice introduction. Before I begin, I would like you to imagine something. I did ask Dr. Thitiphorn before if we would like to build 10 megawatt solar power plant, how much you have to pay? How much? I'm not sure. Anyone know? Maybe 800 million or 100 million baht for one solar project. But PV module technology is But even the PV module technology is very excellent. The location is very ideal and the engineering design is look perfect. Now, if we would like to invest, if you were not confident in the numbers, would you trust the predict energy output? Would you trust the financial return in the carbon reduction claim? Because renewable energy project is built on a technology, but investment is built on trust. The trust begins with the data information. So today I would like to share my why trust data can build by accurate measurement. And this become one of the most strategic assets for clean energy transition. The data without standard is just a noise. It will create many questions to the investor. Maybe not much investor here, but I would like to record this first. Maybe they come back to watch later. The trust, it will create many questions to the investor. Every important decision in renewable energy project need the data. Whether it's engineering, financing, insurance, government policy, but however data is create value when people believe in the method, standards, and the performance. Here it can be said that trust data is a new currency. Next, please. Okay. In traditional energy system, oil and gas meter calibration are very common, but while renewable system, solar, wind energy assets are inherently variable, indicated by climate and seasonal shifts. When energy production has high variability, data become primary assets. It allows us to move beyond the assumption, translate weather data into reliability, and provided the transparency required for multi-million-dollar investment. So accurate data from sensors is bridged between the raw potential, financial, operation, and infrastructure of the project. Next, please. Okay. This is what we talked at the beginning of today. Most people think measurement uncertainty are only technical, but actually measurement error are financials. Every percentage of measurement uncertainty affects project revenue, investor confidence, insurance, warranties, and continuing carbon credit claims. Because a small error at the beginning today with the uncertainty will start become millions of dollars after. They affect every prediction made over next 10 years or 20 years over the lifetime of the long term of renewable energy. Next, please. Yes, when we look deeper, even more measurement error at the beginning, so they can lower the confidence in energy yield. For what they call is like a P90 estimated for project evaluation and higher financing option. In the morning, our colleague talked about the P50, that the data is come from only prediction only for climate. But when you look into P90, that more confidence, they always thinking about the uncertainty, and they will make the P50 even more low confident when it's high uncertainty. That's why measurement excellence is no longer only engineering issue. Today, it has become for business strategy. So after physical resource, trust measurement sensors bring a reliable performance data, bring the precision for the operation and maintenance. Not just technology, not just the business model, not just the tech, it's always having the sensor and measurement behind those numbers. And bankability is ultimately built upon the confidence, and confidence measurement data begins with methodology. Next, please. When we look at the solar project, the trust data is at every stage of their life cycle. In the early feasibility phase, we rely on long-term satellite data to understand variability and select the best site at the beginning. But when it comes to the financing, investor demand very low uncertainty. That's why 1 year of ground-based measurement, such Class A pyranometer, is essential for secure bankability. Finally, during the operation and maintenance, the real-time monitoring ensures the accurate performance analysis, efficient maintenance, and revenue protection. So just as a gas plant, so would never be financed without knowing the exact fuel quality. Solar project must treat the evidence data as there is a fuel for build the confidence and sustainability. Next, please. When look into the performance data, so the pyranometer is very key, but if you use the pyranometer, the sensor is not like a thing that you put on the ground and you just not take care of them. They need, it's alive, sensor is alive. Why? Because sensor can be degraded. Sensor can be sensitive to the environmental, and sensor can be need the calibration. They also somewhat have a physical problem. Even the dust into the pyranometer, they also have a problem. That's why having a reliable pyranometers is very important for solar energy system. Next, please. So the care are be taken to the ISO IEC standard, calibration with a laboratory that traceable to National Metrology Institute, that our colleagues say before that nowadays NIMT can calibrate pyranometers, and also it's not only NIMT can do it, we try to disseminate to the laboratory that usually they calibrate only thermometers, simple electrical meters. Now they should upscale themselves to a little bit more difficult to calibrate pyranometers for serve the solar energy system. And this is also is like a technical shield for risk mitigation. So next, please. Once it comes about the accurate and testable measurement, the methodology become the star. Metrology have no barrier. We have a regional network, comparison data. For at NIMT now, we have a very solid traceability to the quantum SI cryogenic radiometer already established here at NIMT, and we disseminate to traceable data transfer to detector and standard lamp, and can go to give the accuracy to working instrument. This is how the methodology works. It's not only you have one instrument and you just put in your solar farm and maybe you calibrate in the first time and you not do it again and just leave it there. No, the sensor need to keep the accurate and maybe recalibrate every 2 years, and take care have be taken. Next, please. Yes, this is now its work. It's not only Thailand can calibrate pyranometers. We need to establish the calibration and measurement system worldwide and comparable from country by country. Accurate measurement played an important role and important process and help the people that can keep the SI unit ways that to make a decision that really easier and have a trust. Next, please. And this is how we work at NIMT and also international. We are working along with Europe by European Metrology Network, and also we are talking about a new technology that never happened in Asia before. We never talk about a supra-harmonic and something like that. Maybe some country in Europe already know it for maybe 5 years ago, but in Thailand, I heard it only maybe last month about supra-harmonic that come from the inverter that very dangerous for power integrated system. We do capacity building and knowledge transfer among our community. And also we sharing metrology success stories, same as Professor Ravi here with us, and sharing with us about the success story of what he did before in PTB about the hydrogen energy. But in Thailand, we still not start yet. This is a very fast track that how you can establish metrology system and make it easier to and faster and easier to reach the net zero transition. Next, please. Accurate measurement play the role to important process of MRV of energy efficiency and carbon credit accounting, because measurement can establish the trust and comparable data is very important for MRV in terms of in one pillar of measurement. Because the absolute physical is true. Sometimes you just calculation. Maybe you would like to know that what the real emission is. You need the methodology to support this. Okay, next please. This is my last slide. So I would like to ask. I would like to telling you that please don't just ask what technology to buy. Also ask if you can trust the measurement behind the decision. Because trust measurement is chill for the risk mitigation. They reduce the uncertainty. They improve the bankability. They lower investment risk. And ultimately, they accelerate the global energy transition. At APMP EEFG, we believe that accurate measurement is the ultimate risk mitigation, the tools for energy transition. And that is all from my talk today. And thank you very much. Thank you.
Thank you very much. And do you have any question for Dr. Oijai?
Maybe no, already clear. I might have some question for my audience. Okay, all right.
Yes, thank you very much. So please give a big hand to Dr. Oijai, please.
Thank you.
And now she will summarize the events. You summarize, right? Already you did? No? Okay, so she will summarize today's discussion and key highlights. So please welcome her again.
Okay. Not finished yet. Okay, our discussion today reminds us of trust measurement is not only technical foundation, but it's also bridge the connect of science, industry, and society to collaboration and share commitment. We can turn this insight to the impact for the renewable energy and sustainability, of course. I think before we close, I think maybe I would like to invite everyone to give yourself for the big round of applause that you be here from beginning until now, and for your contribution, your ideas, and your spirit of cooperation. That's all my conclusion today.
Thank you very much. The last but not least, may I invite Dr. Jaranya Fa, the Assistant Director of National Institute of Metrology Thailand, to deliver our closing remarks of this symposium. Thank you.
Thank you, Kun Ratanawan. Thanks everyone for staying with us today. I think we have a lot of discussion today, and I think we can foster the collaboration between all of the entities. These are all the national quality infrastructure that need to work together to support the quality of our products and our services. Here is a beginning of talking and also discussion. I hope you can continue this discussion and further to make it more fruitful and make a structure of our national quality infrastructure for clean energy, for sustainable. Make it happen. This is the good example for another field as well. So, Dr. Oijai, I presume Kun Jarwerat as well, and also Ministry of Energy, and also all the testing facility in the country, the research facility as well. You need to work together to make it happen, to make it that this is the example for our NQI to make it, to show the government that with this kind of collaboration, it will make science help in the energy area as well. So please continue the discussion and collaboration. And with our hard work today, I hope that you will go back home and have some rest, and later you need to work on. Thank you very much.
Thank you very much. On behalf of the host, I would like to extend our sincere appreciation to all of you, both here joining at the venues and also joining us online, for making today's International Symposium a great success. We hope you have found today's discussion informative and inspiring, and there will be further collaboration in future. Thank you once again for your participation. We wish you a pleasant evening and safe journey home. We look forward to see you again in future events. Thank you so much. สวัสดีค่ะ